All right, I think we are now live. I'm gonna have to give a quick heads up. My old dog is probably gonna need some help going outside at some point soon here, so I may have to step away briefly at some point to take care of that. But Alan is currently rolling his intro, so I'll give him a second with that.
Hey.
All right, ready to roll whenever you are, buddy.
Excellent. Alan is currently rolling his intro, so yeah. I'll give him a second with that. Let me just pull up Discord in another tab window. For everyone just tuning in, today we're going to talk about Earth's electric field, as evidenced by the Earth's electric field thing on your screen. So yeah, this is Æther Roundtable number 15, and let's get into it. So we're going to start with talking about what a electric field is, or an electric field is, and let's just read specifically from Charles Proteus Steinmetz, PhD, in 1914. This is basically the grandfather of all of current electrical field theory. Tesla's generator wouldn't have worked if Steinmetz didn't come along and make it work for him to basically... It was Tesla's design, but it was Steinmetz who actually made the specifics of the materials used and the dimensionalities that allowed the generators to actually do their job. And in the words of Charles Proteus Steinmetz, the magnetic and the dielectric field of the conductors... Oh, so real quick, what we have here is actually just a depiction of an electric field, and these are actually two electrical conductors. And he says the magnetic and dielectric field of the conductors both are included in the term electric field and are the two components of the electric field of the conductor. So what is magnetic? What is dielectric? Really quick, we have a downward current of around 10 picoamps per square meter on the Earth. And I would kind of suppose that the rotating sky may be creating some kind of a dynamo effect, just a random theoretical concept that could be causing this electrical phenomena. And it would be a unipolar, potentially dynamo. And that creates magneto-kinetic pressure and electropotential tension. And that drives, you have the idea of hydroaerodynamics. And that's actually what drives all of our weather patterns on the Earth. But really underlying that, you would have ether dynamics, which would be the underlying medium that actually causes all the hydroaerodynamics on the Earth are going to be caused by the ether dynamics themselves. And that results in a system of a dynamic system of geology and meteorology in the Earth. And all matter has dielectric potential, even in a vacuum. You can't get rid of that. It's inherent to the matter itself, matter. And I'm not going to read all this, but this is Charles Proteus Steinmetz some more. And just a couple of key points here. To produce a magnetic flux, a magnetomotive force is required. Since the magnetic field is due to the current and is proportional to the current or in a coiled current to the content. Unfortunately, for those of you who heard me earlier, I said I was going to have to step away and help my dog outside really quick. I have to do that right now, so I will be right back.
Please stand by for a brief intermission. Oh.
I missed like the first 2 minutes because I was grabbing that bowl of stew. What did he say in the first 2 minutes?
Yeah, no worries. While he's doing that, we're going to watch Fractal Woman describe a magnet. Just put that on in the background while he's doing that.
Tight. He's basically going over Steinmetz.
Man, that is so cool that there's an ad playing in the background. That's not driving me crazy. All right, cool. So check this out. This is the intro to the video where Feynman is trying to explain a magnet in an interview.
No sound.
No audio?
You're really quiet. Just turn it up. I can hear it. It's just quiet.
There's nothing. All right, I'm back.
Okay, he's back. He's back. Don't worry about it.
I was just catching my breath.
Yep, you're good. You're good.
So
that interview's hilarious anyway. Go ahead.
Back to the presentation. Thanks everyone for holding on there. So yeah, to produce a magnetic flux, a magnetomotive force is required. In empty space, all non-magnetic material turns per centimeter length of magnetic circuit produce equation lines of magnetic force per square centimeter. So, entirely analogous relations exist in the dielectric circuit. To produce dielectric flux, an electromotive force is required, measured in volts. So you have magneto-kinetic pressure, which terminates on itself with these circles here. And then you have dielectric potential tension, which is actually what causes the attraction here. And that's actually goes from one conductor to the other. All right. So on the Earth, we have a geomagnetic field, and it's measurable. North and south poles do not align with the quote-unquote rotational axis. And the magnetos extends into the sky, and that's proposed as the cause of the aurora borealis and aurora australis, and it's used by animals like turtles and birds for migration. Whoops.
Oh, Toby,
Yo. So,
quick
yeah, what's up?
definition of dielectric in this, is that just electrical resistivity?
So no, it's actually referring specifically to dielectricity, which is, let's go back real quick. So you have like electrical conductors here, and this is an electrical field. And this dielectric potential tension right here is actually, it's a potential force, right? This is pure potential. Or the kinetic pressure is basically just it's pure motion or pure kinetic energy, and then this is pure potential energy. But this would be, you see it when there's differentials in the, and essentially in the current, right? But so dielectricity is not necessarily the same thing as dielectric materials, which is kind of like the idea of insulation, right? But really it comes down to, what's the word? Like resistance and, the tongue starts with an I.
Impedance.
Not impedance, but same idea, essentially. So, in any case, 1 second, sorry.
Oh, impetus? Or impotence?
All right, sorry, my dog's like really heavy and I had to carry him. I'm like still catching my breath. All right, so on the Earth we have a voltage gradient, and there's a vertical electric field in the air, and there's a negative charge of ground, right? And horizontal to the ground, we have equipotential lines that go up at 100 volts per meter, and there's actually 200 volts at your nose. But you don't get shocked at your nose all the time. You don't have electricity running through your body all the time because you're actually grounded. And so the lines of equipotential actually kind of curve up and around you. And this actually happens with buildings in the sky. It goes all the way up. There's like the gradient actually kind of bends all the way around the grounded buildings. But, if you were to say jump out of the building or something, you would, it's relative to the amount of grounding that you have, right? So you wouldn't necessarily, like, as the current is coming down, you can't just be grounded and ignore the downward current, because this is not necessarily like a perfect grounding, right? But in any case, this is measurable, and so let's get into this slide. So there's actually a difference, a potential of 400,000 volts between the surface of the Earth and the quote-unquote top of the atmosphere, and this is from the Feynman lecture, and he says the total, he's just him saying the same thing, right? And so, so there's a current in the atmosphere, which I've already mentioned, but it's measurable. It passes from the sky down to the Earth, and there's a massive volume of dielectric permeability, and that's actually the word I was trying to think of earlier was permeability, right? But so our air is actually has a massive amount of dielectric permeability. And even with that, there's 10 picoamps per square meter each second that passes of current through the ground, or through the atmos, from the quote unquote positively charged field in the sky down to the negatively charged ground. And so this is also just from, this is, Feynman quoting the same thing right here. So this is from a paper, an overview of Earth's global electric circuit and atmospheric conductivity. And detailed measurements made to the Earth's surface show that Ohm's law relates to the vertical electric field and current density to air conductivity. Stratospheric balloon measurements launched from Antarctica confirm the downward current density under fair weather conditions. And then, they talk about solar energy particles, and they talk about their recent modeling, which we'll get into that in a little bit here. But it says it considers lightning discharge effects on the ionosphere's current electric potential. And then they conclude that cloud-to-ground lightning discharges make only a small contribution to the ionospheric potential, and we'll also get into that in a bit. So moving on. So we have a charged sky, and among air molecules here and there's an ion, a molecule of oxygen, say, which has acquired an extra electron or perhaps lost one. And this is also from Richard Feynman. I'm quoting a lot from his Electricity in the Atmosphere lecture in this, but it's just kind of a good starting ground for our basic understanding of the electrical field. Each ion then becomes a lump, with other lumps drifts in the field, slowly moving upward or downward. A lot of this is speculation. I'm kind of taking it. Our understanding of ions seems to be a bit fuzzy. And then he says, it was first guessed that ions were produced by the radioactivity of the Earth. This would imply, of course, that if it were to go higher altitudes, we should find less ionization, because they thought it was coming from radium, uranium, potassium. They thought that's what was causing the ionosphere, or causing ionization of our atmosphere, right? But then when they started actually testing it, they actually went up with balloons. They found out it was exactly the opposite. The ionization actually went up as you went higher in altitude. So along comes William Francis Gray Swan. He came up with the idea that cosmic rays keep the ionosphere positively charged, and then he had 2 moon craters named after him. And this is his work here, The Earth's Electric Charge. He talks about how the Earth is negatively charged, and he talks about the electric potential gradient, and then he talks about how there's a very low conductivity of the atmosphere, but he does talk about the current, and he says that this small conductivity is sufficient to ensure that 90% of the Earth's charge would disappear in 10 minutes if there were no means of replenishing the loss. The nature of this replenishment is the greatest of the outstanding problems of atmospheric electricity. So, what are we going to do about that? He says, he brings up cosmic rays. He says, for many years we have information pointing to the existence of a very penetrating radiation of a hard ray type, which enters our atmosphere from outside and breaks up some of its molecules into positive and negative charges. The source of this radiation is one of the most interesting speculations of cosmical physics today. By means of this radiation, it is possible to visualize one method by which the Earth's charge may be maintained. Sorry, taking a drink of water. For we know that when such rays eject electrons from atoms, they hurl them in the directions of their own line of flight. The cosmic rays are like bullets fired downwards from a lot of guns in space, and the electrons, which are knocked out of the atoms by these bullets, continue their downward flight. So there you go. Positively charged sky, just a bunch of guns in space. And so
Checks
then he
out.
says, this part here is interesting. This is kind of like his kind of like a truth in plain sight type of thing. He says, it is possible to adopt an entirely different view as the origin of the Earth's charge. Modern theory teaches us that the structure of matter is electrical. A cubic centimeter of the Earth contains so much positive and negative electricity that if these amounts could be separated and concentrated at 2 points in 1 centimeter apart, they would attract each other with a force of 100 million tons. A very, very slow but continual death of the positive electricity would leave a surplus of negative sufficient to provide for the atmospheric electric current. As a matter of fact, To account for the atmospheric electric current, it would be sufficient to assume a rate of death which was so slow that only 1/2% of the Earth's mass would disappear in 100 million years. So, what is he talking about when he's talking about this charged sky that's getting hit by guns in space? He's talking about what they call as the ionosphere. I'm going to call it today the ionos. Alan also proposed maybe we could call it the ionoplane. But I think since we use the word atmos, we could just use the word ionos. Michael Faraday first used the term ion in 1834 to describe substances that carry a charge. The Greek word is ion, and it just means to go. So the charged field in the sky is positively ionized, and it's going to go down to the ground, I guess, slowly through that current that we talked about. So yeah, talking about cosmic rays, here is ChatGPT 4.0's quick little description of what a cosmic ray is for those of us that maybe don't know. Cosmic rays are high-energy particles that originate from outer space and travel at nearly the speed of light. They primarily consist of protons and atomic nuclei from elements like helium, carbon, and oxygen, but can also include electrons and positrons. Cosmic rays can originate from the sun or other stars or outside our galaxy, often produced by supernova explosions or other high-energy events in the universe. When these particles enter the Earth's atmosphere, they can collide with the atmospheric atoms, creating a cascade of secondary particles that can sometimes be detected on Earth's surface. They can sometimes be detected. We know they're there. Sometimes we can detect them.
Wait a second. So they're not detecting the cosmic rays. They're detecting like the electrons that are given off because of the cosmic rays. They're saying.
Yeah, they get a muon here and there, essentially.
Fucking muon.
So they don't directly measure them.
No, well. No, they model them. They model them all crap load. We'll get into that. Cosmic rays have been ascribed as the primary source or the primary cause of the positively charged ionos. We got into WFG Swan. That was the guy that came up with that. And cosmic ray predictive simulations are inaccurate because what do you know? Cosmic rays have been used for random number generation. So if you're trying to use something that you could use for random number generation, and you're going to try and make a predictive simulation about that, good luck. And actually, look, what do you know? They're looking into using cosmic rays to generate and distribute random numbers and boost security for local devices and networks. And how this works is that there would be a muon detecting apparatus at each location that would be used with a timestamp, and they would use that muon detection to then encrypt. They would use that for their salt and their encryption or something along those lines. So let's try and simulate it. So when I first started looking into this, I was like, all right, so the sky is positively charged. Where does that come from? What's causing that? So I started trying to look into it. I was really interested in, I guess, the ionosphere, right? Well, all you can find is a bunch of stuff about proxy data. Some emphasis is placed on numerical modeling. They're still trying to find a research framework to concentrate on. Numerical models are discussed, calibrated to observations, but that's just a new methodology they're presenting. But this one, most of the recent models they're talking about, they're computing everything. Just computed several cool paper. I can read about your computer simulation. That's pretty neat. Here's a couple more. Electron precipitation. We propose a favorable method for the computation of ionized rates using EEP, using a new parameterization of ion production in a new spectrum shape. Fun. Computed energy particles, computed a function of the altitude above sea level using reconstructed solar energy particle spectra, which is not precise measurements, right? This is based on some observations that they then build simulations on. And so, here's a whole paper. Ionization in the atmosphere. Comparison between measurements and simulations. Some discrepancies are found. Who would have thought? Quick 20 seconds. All right. Sorry about that. So, the Earth's ground has a net negative charge in contrast to the positively charged sky. The ground is estimated to be around negative 500,000 to negative 1 million coulombs. and it's not very well understood. There's an excess of positively charged air ions are known to be observed in underground rooms with poor ventilation. And so, like, where is the negative electrode of the Earth's capacitor located? If we're running into positively charged ions in rooms in low elevation with poor ventilation, where does that come from? And so this whole paper is actually talking about how they're proposing a hydritic Earth model, which is basically the outer core and the mantle of the Earth must contain metal hydrides and metals respectively. But the problem is that doesn't work with the geodynamo model. The geodynamo model has very specific molten metals that must be present in the inner and outer core of the Earth. So they can't have also a bunch of hydrides thrown in there all of a sudden. That messes the whole thing up. So they get into this whole crazy thing about this whole system of high temperature hydrogen dissolved in metals loses the electron, and subsequently there exist only separate free protons and electrons diffusing in the metal separately. The proton mobility increases with rising temperature of the medium. As a result of this property, the upward propagating hot protons from narrow jets, transferring the temperature of hot lower layers around. We will call these protons hot. The protons and electrons that reach the crust mantle boundary behave differently. The electrons do not pass into the crust. So this is just like another crazy simulation model, and it's totally ad hoc to the geodynamo. Like, hey, we could do a hydritic model, and then we can maybe kind of explain the negatively charged ground. But then also, don't forget we've got a geodynamo, and then we can use that when we need to explain the Earth's magnetic field. Can't really use both. Kind of like how with the orbits, you can have you can have one orbit. And then you can have another orbit, but you can't have both at the same time. They can't do the math. They can't even do the kinematic math to make that work, or they can't make that kinematic math line up with each other, essentially. So, on the Earth, back to the subject at hand, there is actually a daily electrical impulse. And measurements of Earth's current over the sea are more stable. So they use those to take analysis all over the Earth, and that reveals a synchronized daily variation in the current of around plus or minus 15%. And the maximum current occurs at 7 p.m. London time everywhere in the world. So not just 7 p.m. here, we have the highest current. 7 p.m. there, we have the highest current. No, at 7 p.m. London time, the highest current is everywhere in the world. And the minimum current occurs at 4 a.m. London time. And that depends on the absolute time of the Earth, not the local time at the place of observation. It implies a uniform charge distribution. So you would have to have parallel gradient lines, or at least equipotential gradient lines. Concentric spheres doesn't work so well for that, because you'd have problems distributing the electrical charge in these concentric spheres. The charge wouldn't balance out. It wouldn't balance out perfectly like it does at equidistant lines. And so this is just Feynman lecture, same thing, him saying the same thing. But they did measure this. This is the British Geological Survey. This is just showing one of the ways that they measure this. And you can see here 2 different locations showing the same electrical impulse times. 2 electrode pairs are used in a north-south and east-west configuration to capture the strength and direction of the surface electric field vector. The electrodes are spaced separately 100 meters apart and are located as far as possible from locations of cultural noise and non-natural conductive structures. Examples given: buried pipes and cables. So here's Richard Feynman. It is not going to be possible to describe exactly how a thunderstorm works, because we don't know yet very much. And here's just this summer, or last summer, new satellites to help scientists better understand how thunderstorms develop. They're sending some new satellites up, 177 million. They're, Rasmussen is a team of researchers at CSU that is leading a NASA mission that will give us a never-before-seen glimpse into a thunderstorm. So, yeah. Let's talk about what they say we know about thunderstorms. So, thunderstorm cells are horizontal regions. So, cells, these things here, are horizontal regions in which processes occur. And general rising of the air with velocities highest near the top. That's what happens in the cell. And warm, moist air rises from the bottom. As the air rises, it cools, and it condenses. The moisture condenses. Additional cool air is entrained from the sides of the updraft, and the warm updraft radiates heat, which causes unstable thermodynamics. So then you get into a mature thunderstorm. And rising warm air expands adiabatically. Condensing water liberates heat, and it leaves moist, cooler air as it rises. So as the water condenses up there, the air doesn't actually retain any of its heat because the heat all gets out with the condensing water. And then cooler, heavier air remains at a lower level. And then warm and moist air can reach enormous heights, and there's upward draft of average around 60 miles per hour in an average thunderstorm cell. And then crystals and particles must be present for the water to freeze. You actually can't have anything freeze unless you have a nuclei, which the best nuclei is salt, NaCl. You actually have to have salt in order for the rain to actually happen, which is really fascinating. And then water will drop below freezing before crystallizing in the absence of nuclei. And once heavy enough, ice and water particles will begin to fall, starting a downdraft. Once started, the downdraft will maintain itself. I'm going to take a quick drink of water. And so then now we have a late phase storm cell. The updraft stops once there is no longer warm air. The last bits of water precipitate. Things quiet down. Small ice crystals are leapt up in the air. The top of the cloud spreads out into an anvil shape. And then the thunderstorm cell reaches the end of its life. So now let's talk specifically about lightning. And this is again from Feynman. The moment at which precipitation starts is the same moment that the large downdraft begins. And is the same moment, in fact, when the electrical phenomena arise. And he says, so actually it's kind of interesting. One other thing that they say is that the negatively charged ground is actually caused by lightning. They say that this is what causes our ground to be negatively charged. And this is actually Feynman saying just as much. He says the predominantly negative charge at the bottom and the positive charge at the top have the correct sign for a battery needed to drive the Earth negative. So they need cosmic rays for the top. And then they say that somehow, just like a little bit of friction in the atmosphere, in their atmosphere allows them to have, enough lightning to keep the Earth down to like a negative 100,000 columns. All right, and then just here's Feynman's conception of lightning, or the charge of a thundercloud storm, or of a storm head. Won't go too much into this, although they don't really know. Just mention here, they can't really even explain this little positively charged area here. They don't really know what happens. They have a few theories about raindrops catching positive nuclei on their way down, but it doesn't really make any sense because if the bottom of the raindrop is negatively charged, then it would actually push away the positive, or if the bottom of the raindrop is, I don't know. I'll just say that they don't have good explanations for this necessarily, unless there's something new that I don't know of. Large voltages break down in the air. This is how lightning works. Large voltages break down in the air. Lightning strokes can occur from one cloud to another, from cloud to earth, or earth to cloud. And actually also from earth to earth. We'll get into that in a little bit. And there's around 20 to 30 columns of charge that are brought down, quote unquote. And there's a measurable sudden decrease in the field when lightning strikes. But that's followed by an immediate exponential return to the previous value, but with a new geometry. And what that means is there's an idea of there's leaders that can occur before the lightning can actually strike. It can actually start to create like a conductive path in the atmosphere of specifically ionized, ionized a specific way so that it's like starting to work its way towards the ground before the actual strike happens, the actual discharge of the dielectric energy happens. And when but once that happens, now the charge is all totally changed. And so even though it's going to, within 5 seconds, it'll be right back up to its original charge, it's not going to have the same geometry. It's not going to have that same leader out ahead of it for it to, strike through. And the pattern is irregular because, like I said, it's just a different geometry every time. And there's around 4 amps of current in the thunderstorms. So that means it's like a rapidly operating system with massive voltages, because 4 amps is not a lot for what what we witnessed during a storm. And we just talked about thunderstorms and lightning, but then there's also this idea of transient luminous events. And basically, these are just transient electrical field phenomena in the positively charged sky. To us, it's really cool that they're luminous. We think it's so cool that we can see them. If we were looking at little like electrical sparks on a little, like a board or so, electrical board, that wouldn't really necessarily what we would be so focused on. We'd be more focused on the actual transient electrical phenomena that's occurring there, or electromagnetical phenomena that's occurring there. So there's some kind of electromagnetic phenomena occurring with the elves. Some people would say that this appears to be occurring from within some kind of a fluid. I would definitely say that it's not so straightforward as what this is. Also, these ghosts here, these are a newly discovered phenomena. And it actually, some people say that it's the same luminescence that we see during Aurora Borealis that occurs after the sprites strike. The ghost is left, it's a brief little flash of like a green luminescence that's left in its wake. But we'll move on here. So, eddy currents. They were discovered by Foucault in 1851, and these unequivocally exist on the Earth. There's circulating currents that are induced by a moving magnetic field, and the flow is induced perpendicular to the magnetic field. It induces Joule heating due to resistive effects, and it was discovered. And Maurice Elias believed that eddy currents on the Earth were the key to the precession of the pendulum. So let me just go full screen here. Here we go. So just going to read through Elias's quotes here. Again, we see that the total amplitudes of the 13 components above for the June to July 1955 azimuth series are of the order of half of the Foucault effect. The forces involved are therefore of the order of magnitude of the eddy current force, corresponding to all I have of that. But yeah, it's corresponding to the eddy current force. And then he says, in both cases, the angular deviations observed per unit are of the same order of magnitude as of those corresponding to the eddy current effect. We can deduce that the forces involved in the observed perturbations are of the same order of magnitude of the Foucault effect. So these deviations are totally inexplicable in the framework of gravitational theory. And if it looks weird, it's because it's translated from French by an AI. But that's from Maurice Elias's 1997 the anisotropy of space. Anisotropy of space. So let's get into cyclones and hurricanes.
Real quick, Toby.
Yeah, what's up?
That last sentence on the slide. Can you go back to the last sentence? So they're totally inexplicable within the framework of current gravitational theory. Is that because it would suggest that like electromagnetic forces are causing motion when those are supposed to be like way stronger than gravity? So that would kind of like those two things would contradict with each other if that was happening. Is that why it's inexplicable? Like, why is it inexplicable?
Yeah, essentially. Especially because they try to invoke gravity to explain the precession of the pendulum along with the rotation of the Earth. So, like there's a specific rate at which the precession should occur. So if the precession occurs at any other rate, it implies that there's more going on within the motion of the pendulum, and of, that would basically imply all of Coriolis, right?
Yeah, except the fact that it changes during an eclipse, if it was due to the Earth's rotation, the Coriolis effect, and the pendulum precession, it would have to mean that the Earth is like spinning faster, right?
Yeah, which is, obviously that's not occurring during the
Right.
eclipse, right? Like this, it's not just speeding up during the eclipse and slowing down during the eclipse.
Right. Okay.
All right, so back to the presentation here. Oops. Sorry about that. All right, so cyclones and hurricanes. And let me actually go here. So they start as tropical storms over warm ocean water, and then those tropical storms develop high winds and a low pressure center. And hurricane season, just if anyone doesn't know, hurricane season is the opposite in the north than it is in the south. Kind of common sense, right? But hurricanes never occur on the equator, and they never cross the equator. And actually, if you look in the lower left picture here, you see these arrows that diverge outwards. When you see this curve here, you kind of would be thinking, if you haven't like looked at cyclone geometry and hurricane geometry a lot, you may think that the cyclone or the hurricane would be doing a rotation, a clockwise rotation, right? But it's actually doing a counterclockwise rotation in the north. And so that counterclockwise rotation is occurring as the hurricane is doing this curve back outwards. And all of them kind of do this like outwards motion away from the equator. So you have essentially like a sun motion that goes through here, right? And as the sun motion occurs, it pulls an inward rotation that then moves outward. And just to visualize what that looks like from a top-down map, we have this here, right? So you would have the sun going around here, and then you would have the cyclones and hurricanes would be the cyclones in the south would be going this way, going clockwise, and then the hurricanes in the north would be going counterclockwise. So I think that this is related to the eddy currents that are being, that are manifesting on the Earth as a result of the sun and the moon going throughout their motion throughout their sidereal motion throughout the year. And that actually goes pretty well with this as well, right? You've got these massive spinning storms that are occurring as the sun moves up and down on its analemma. So now moving on, we have the idea of luminous earthquakes. Luminous flashes have been observed during seismic activity. The presumed cause is friction and electrical charge separation in rocks. So either friction from something moving underground, or an actual, like a popping of a rock that had an electrical charge in it, and that electrical charge then escapes out of that rock, and that causes some kind of, like a discharge from earth to earth, essentially. Like I mentioned earlier, we'd be getting into a little bit of earth to earth electrical discharge. But it's actually not actually even as simple as that. It's visible at the ground and also from the atmosphere, according to NASA. And it's still being studied, not well understood. Here is probably the most popular one, or at least one of the most famous ones. This is from 1968 in Mount Kimyo, Japan. And it's just like a bright flash. And these are witnessed before the earthquakes. So there's some kind of electrical phenomena happening before the actual earthquake occurs. And then this is Mexico City in 2021. And that's actually what this one was in the background here as well, was Mexico City 2021. Pretty fascinating stuff. And then volcanoes. Discharges can occur in the rocks around the volcano. The triboelectric effect is known to produce static charges as particles collide in the plume. I mean, that's the going theory, at least. Fractal emission and radioactive charging can also contribute to the overall charge. In taller plumes, the moisture in the air can contribute to the lightning activity. So you get, like this says here, you actually can get them from into the rocks around the volcano. It can occur, from the plume itself, or also like literally rock to rock, from the emergence of the volcano right out to another rock. Pretty interesting. Let me actually get off of the. There we go. So that we can actually see that lightning there, because that one's pretty cool.
So basically, they claim that the electrical stuff in relation to it is a symptom, and it's actually a cause.
I wouldn't necessarily go that far of a leap with it. It's possible, I guess. I would actually say it is a symptom, right? I think everything is just statically electric, and so static electrics are just ever present in our atmosphere, in our atmos, in our Earth field. So Aurora Borealis, the quote-unquote Northern Lights, They say this is caused by solar winds colliding with atmospheric gas, and the lights dance in the sky. And they're usually in the north, they're usually emerald green, but they can be pink, purple, red, and blue. Extremely famous, wonderful phenomena. I've never seen them myself, sadly. But here's a couple pictures of Aurora Borealis. Very beautiful emerald green color. And then Aurora Australis. This is the southern lights. And they say this is also caused by solar winds colliding with atmospheric glass. It's a little bit less frequently documented, and it's typically pink and orange. I thought that was pretty interesting when I was looking into this. These typically seem to look pretty different. Now this picture clearly to me looks like they did a lot of work in Lightroom or something. They really jacked up the saturation, but it's still a really interesting pink. Here's another one with a really interesting pink and yellowish orange. So pretty different looking than Borealis, although they both, I supposedly they both can make like all the different colors, but these are by far the most typical colors of these phenomena. And so finally, just to close it out here, let's talk about the gravity equivalence that exists straight up. There is, there are gravity mechanisms in the world are unsubstantiated on any scale, quantum to cosmological. It's purely a mathematical description of the downward accelerating force. Faraday, Maxwell, Tesla, even Einstein, many other famous physicists throughout history have all speculated as to the electrical field's relationship with Earth's downward bias. The kinematic equivalence has been demonstrated many times. It's pure kinematics anyways. But just to show, here's two different papers. Here's Konstantin Meis, and he wrote the electromagnetic nature of gravitation and matter, antimatter, anti-gravity, surmise on quantum vacuum gravitation and cosmology. The equivalence between Newton's gravitational law and Coulomb's electrostatic law results naturally. That's what's in red right here. And then this was Morton F. Spears at the Iowa State University, and he said he presented a comprehensive new way to perceiving and understanding gravity forces, and he uses just this totally kinematic idea of different atomic numbers or atomic masses, and derives essentially big and little g using electrostatics. But that's all. Thank you everybody for listening. Thanks for bearing with me while I had to step away to let my dog outside. Yeah. That will.
Thanks, bro.
Dude, awesome presentation, bro. You crushed it.
Hell yeah. Actually, a good presentation, brother. And you were right. It did last 20 minutes. That was great. It's perfect.
Yeah. 45 minutes. Wow. I felt like it was going to be a lot longer.
Yeah.
Hey, no, you know what's really interesting though is you brought up volcanoes and discharges with volcanoes and earthquakes and shit like that. And I always thought there was some type of evidence to that, right? Where it's like some type of electrical discharge rather than actually mechanical things moving beneath us. Does that make sense? Like it's not fucking.
Yeah, like you
Not
could
a
shoot
core.
the earth with electricity and trigger an earthquake.
All right.
Top stuff. Yeah.
So yeah, what did you guys think about the hurricanes?
That was cool.
Can you go back to that slide?
Yeah, and that makes a lot of sense. You know what it reminds me of too when you have the picture of the hurricanes? Remember the I can't remember her name. I think her name is like Physics Woman or something like that. Where she has like the plate and she like pushes the pool.
Yeah.
It's exactly what it reminds me of.
Dude, totally. And it's a counter rotation though, I think, because of, I don't know, it could be related to like a diamagnetic inductance or maybe a magnetic inductance or something, I'm thinking. Or also something I didn't even mention is that we don't even know for sure if the ether flow goes the same way in the south. It literally could just be
Yeah, I was just thinking that.
like it
It
literally
could
could just
just
be like, oh,
be.
ether flow this way, ether flow this way. What do you know? You get opposite rotations.
That would
Yeah.
suggest that the sun is the big electromagnetic motor driving it all.
And or moon. Or just that, or just specifically the equatorial, the ether wind vector, specifically at the equatorial latitude, is the
You,
greatest,
you,
right?
yeah, you need to see if it varied with the sun's equator or just the absolute equator.
If what varied?
Like the axis of the rotation, like clockwise versus counterclockwise, if the axis is always perfectly equatorial, or if it like more closely matches like the sun's circle it's making between the tropics.
Well, it definitely has some sort of correlation to the sun and moon, according to Miller and Elias.
Hmm. I'm just saying which is more powerful would be you would know, right?
Wow, only 45 minutes. Jeez, oh, Pete's. Was so much research just to get 45 minutes.
Well, let's go over
No,
some
but
things, bro.
there was a lot of information in there, dude. Can you go back to the first slide?
Steinmetz.
Yeah. So yeah, the owl right there. Can we go over the owl again? Because this is really important. I was just watching Fractal Woman earlier today go over this, and yeah, if you want to just go over this again.
Yeah, plus I was kind of out of breath when I did it earlier.
Yeah, dude. This is epic, bro. You went over so many good concepts, and at the end there, when you were talking about the kinematics, how they derived little g and big G from the same concepts, right, from electricity, essentially, right? So that shows that when they applied those kinematic equations to the sky, right, and then when they found more stuff, when the optics got better in the solar systems, and they could no longer explain it with their kinematics, it started to fail, right? And then with Michelson-Morley, the forces, if they existed in the way that they were applying them to the sky, would reflect in interferometry, and they didn't. So like the all we have is an ether drift, measurement in uh, in electricity, right? That provides an actual mechanism for a downward current or downward acceleration.
These eddy currents, bro, like, can you touch on those a little more, exactly what those are?
Yeah, I mean, so it's essentially just currents in the air, electrical currents in the air that occur as a result of motion of magneto-kinetic pressure.
And an eddy is a vortex.
Yes, and it's a vortex.
vortex.
Yes. Now on like in a stream, you get rotational eddies that would go like. If I
Right.
go back to the, let me go back to the. It's easiest if I just. Like in a stream, the eddies would actually go like as the sun would come through here, the eddies would go this way. They would rotate clockwise in relation to the sun going from west to east. They go clockwise underneath, and they would go. Wait, is that right? All right, sorry, east to west. So, yeah, they would go clockwise in the north and counterclockwise in the south, with like eddy currents in the water. But I think because of the diamagnetic nature of the air, or of the medium, potentially that I'm not totally sure, but I think that the eddy currents are actually inducting the atmos, and that's actually what causes the counter rotational cyclones and hurricanes. If that makes any sense. But eddy currents, yeah, they're the essential the resultant phenomena of magnetic motion, is my understanding.
Yeah, first time I heard about eddies, right, was from like Randall Carlson, who was talking about the vorticular eddies, high powerful eddies that basically from giant whirlpools from fast moving water, right? Like when you make a whirlpool in a pool, you're moving it you're moving it very fast in a sense, like you're moving your hand down, right, causing that pressure to pull it down. That pulling down creates that vortex. So essentially, something is pulling as one is moving across the tropics. In a sense, I don't know. I still feel like it's like that plate. Physics lady, do you know what I'm talking about?
Or physics
What's
girl,
her name?
I think.
Physics
Yeah,
girl.
yeah.
Yeah, that makes a lot of sense. Now, granted, that's a force, right? But, yeah, I don't know. I don't know how else to articulate it, but I totally get.
So fractal woman, this verbiage right here, magneto-kinetic pressure and dielectric potential tension. These are fractal woman's verbiage, but I like it. I think it's a good description. But we can just go ahead and read Charles Proteus Steinmetz here. We'll read everything. All the lines of magnetic force are closed upon themselves. All the lines of dielectric force terminate at the conductors. So that's the dielectric potential tension and the magneto-kinetic pressure. The magnetic field and the dielectric field thus can be considered as a magnetic circuit and a dielectric circuit. To produce a magnetic flux, a magnetomotive force is required. Since the magnetic field is due to the current and is proportional to the current, or in a coiled circuit, to the current times and the number of turns, magnetomotive force is expressed as current turns or ampere turns. In empty space, and therefore also with very close approximation, in all non-magnetic material, F ampere turns per centimeter length of magnetic circuit produce H equals 4 pi F 10 to the negative 10 lines of magnetic force per square centimeter section of the magnetic circuit. Hence, the factor 10 to the negative 1 results from the ampere being 10 to the negative 1 of the absolute CGS of the unit or CGS unit of the current. Entirely analogous relations exist in the dielectric circuit. To produce a dielectric flux, an electromotive force E is required, which is measured in volts. The EMF per unit length of the dielectric circuit is called the electrifying force or the voltage gradient, and is so. With this idea of a conjugate geometric expression, right? That's what's going on with the relationship of a dielectric force or a dielectric field and a magnetic circuit, is that those two things are a conjugate geometric expression. And when you see like iron filings sprawled out on a table around a bar magnet, and what you will actually see, you won't see these circles, right? You won't see those. You'll see the lines, these lines, right? Like let's say you had a pole, like a bar magnet right here. Those lines are actually the dielectric potential tension that you see. You don't see the magnetokinetic pressure until the ferrocell comes along. That's what allows us to actually see magnetokinetic pressure. So, yeah, and it's interesting how, the dielectric potential tension, he specifically, Charles Proteus Steinmetz talks about a voltage gradient in reference to the electric field here, and that corresponds to the length of the dielectric circuit. Pretty interesting.
So you're saying the circular lines, they're not visible. You would actually see the dotted lines.
Yeah, that's what you see with the dotted lines are what you see with a magnet.
Iron filings.
Yeah, with iron filings on a magnet. Yeah, exactly.
So you can't necessarily see the pressure, the pulling, the downward force in a sense. That flux, because we're basically looking at it top down with the owl.
Yeah, exactly.
Do you see what I'm saying?
So
yeah.
Technically, this is actually power lines, right? This would be like if you took two power lines next to each other and cut them, you'd be looking at it like horizontally. That's technically what this is, but you end up it's still just an illustration. It's just a good illustration of an electrical field.
Right. It's interesting though.
I put a screenshot of the magnetic filings to the side or in the live chat.
Yo, Toby, I just wanted to tell you thanks for putting all the work into it, because you study it out, you lay it down, and then it's shareable. It's truth. We can hear that you've done the research. Anyone can double check what you're looking into, and this is just more fuel to, on the fire of making the truth heard again. It's very exciting.
Yeah, absolutely. Thanks, Toby.
Thanks, Yo. Yeah, and I'll probably do it again in like a month or two, with it a little bit more polished out, or maybe who knows when, but at some point. But thanks, Yo.
Yeah, dude. It's a good presentation. I'm thinking like Paizo's thinking right now about the sun being the motive force, right?
Yeah.
But that's not necessarily saying that it's there. Like it's like what we're actually seeing, the sun's path is actually like it's not, I don't think it's physically there. That's just my opinion, it's my theory. Like this is leaning more towards, for me anyway, that the sun's like the black hole sun, and that we're actually seeing like the moon is actually like the after image of the sun and vice versa. It's like the split of it. I don't know how to
I'm still
describe
trying
it.
to. I'm trying to get that dielectricity like down pat. What that explanation is, exactly what that is. Dielectricity, not dielectrical properties, but dielectricity.
Yeah, so also like all lightning is dielectricity. It's
Right.
it's all static electricity occurring.
But static electricity, right? Like when it moves, does that, like, you know what I'm saying? Because lightning's moving. Is it like a? Are you saying? Hold on. Are you saying that the lightning is like a bridged connection in the static electricity, whereas electricity is actually itself flowing? So dielectricity is like a bridged static connection.
Well, so really it's just like a more complete way to look at an electrical circuit, right? Or an electrical field. There's always present in every electrical field, in every electrical circuit, you would have magnetism and dielectricity, and that's what makes up the actual current, like the full like AC currents. Like that's why generators, alternators, like they all have
Coil shape. Yeah.
like a magneto component, right?
Yeah, the thing is that's tripping me out is that go ahead.
I'm sorry. I didn't mean to interrupt you.
No. I'm losing my words anyway. Go for it.
Well, it's like I'm trying to figure out what the interactivity between like dielectricity and electricity is, right? Like if you were to have electricity and dielectricity at the same time next to each other, right? Like let's say your lightning strike, and then you had like a power station with like an arc emitter, right, or two arc posts, and had an arc between them, right, in the like a parallel line right next to the lightning strike. Like, would they look different? Would they have different properties? Like, I mean, we could even try to,
it's just two different ways to look at it, right? Like, all electrical energy would essentially, at some point, originate as a resultant, as a result of the conjugate between dielectricity and magnetism. Like, no matter what, even if it comes from a battery, like how did that battery get charged? In some way, shape, or form, it originated as part of the conjugate between magnetism and dielectricity.
So electricity is dielectricity and magnetism conjoined. You're saying?
Yes, that's my understanding. It's just like a more complete way to look at it. Actually, really, you would call it you'd call it electricity and electromagnetism would kind of be like a more complete picture, I guess.
Okay, so dielectromagnetism equals electricity.
It's almost like you can't have one without the other.
Yeah, I'm just wondering because if that would suggest that, like, whereas resistance is like the resistance to the flow of the electricity, it would have like an inversely proportional correlation with magnetism compared to what it does with electricity.
Yes, sir. True.
Yeah.
And that's actually really crucial. Like when we were talking about the atmosphere earlier, and we're talking about the permeability or the it would be permeability of the atmos, and also really the permittivity of the atmos as well would both be relevant.
So the less electrically inductive a material is, the more magnetically inductive it is.
I'm not sure about that.
Yeah, I was gonna say, is there a correlation at all?
I don't think so necessarily. You can have good conductors that are diamagnetic and magnetic, I think, or ferromagnetic, and vice versa, I believe. I'm not really sure.
Okay. Hmm.
That's a whole other rabbit hole I've yet to really dive into.
It's the crystal structure, geometric crystal structure of the molecules of whatever particular element is the conductor.
It definitely seems that like quartz is literally like a dielectric insulator, but then it also seems to produce dielectric currents, which is really interesting.
Yeah, the crystal structure of it pretty much seems as if it has a relationship where it can like meaningfully vibrate the ether. Like when it experiences vibration, it also vibrates the ether, whereas normal matter does not have that effect upon the ether. It's superfluous to it. That appears to be like the emergent property by which it has like a mechanism of interaction.
So, what's the difference between dielectric permittivity versus permeability? If there is dielectric permittivity in the Atmos. Because
so I believe permittivity would be referring to capacitance essentially, and storage essentially.
Of Earth. Right.
No, it would be the
Drive it backwards.
the impedance on an electric current, and then the permeability would be the impedance on a magnetic current or
Thank you,
field.
sir.
Okay.
Okay.
I just thought of a really, really good analogy about, I know it's like related but not the same, about like electricity and resistivity when it comes to, piezo crystals. The piezoelectric crystal is like a sponge, right? The sponge knows, like, that there's water in the sponge, and the water is the electricity, the juice, the ether, whatever. So the juice is in the sponge. If you squeeze the sponge, the juice comes out, right? And so, like, quartz crystals are kind of like sponges, whereas piezoresistant materials like silicon, they're like screens. It's like a screen, right? And when like water flows through the screen, that's the interaction right there. So that drives like the inverse effect. So
sorry, go ahead, bro.
So whereas one is like compression, by the ether or whatever, the other one is motion through the ether. So it's like all matter gets dragged through ether, and all matter can be compressed, but it doesn't have that like grab it, effect that these crystal structures do. It seems that the crystal structure of a substance is completely independent of whether it's got like high magnetic properties, high electrical properties, right? Because you have conductors that are, like the same as certain insulators and certain properties, and then vice versa. So it's like the geometry is inherently different than the conductivity or resistivity. So you have to have like a different source other than geometry for those properties.
Yo, real quick, you guys want to watch this magneto-hydrodynamics video that Sacred shared?
Absolutely.
Yes.
Cool. Let me know when you guys are queued up.
Magneto-hydrodynamics.
Go ahead.
Yeah.
Oh.
Whoa.
Hey, yo.
Hold on a minute.
Yo, is that what I think I just saw?
Yeah.
Is that a counter-rotating field induced by a top-down flow?
Oh my gosh.
Yo, Sacred, my man. What?
And yeah, almost like
Here,
Yeah.
let's turn off the music.
Just a little quick pause for y'all.
You don't like the music?
Fuck, dude.
I can't hear it.
5x speed.
Can't hear it.
Oh, thank God. I just
God
want to see
bless.
it.
Yo, that is. Yeah, we're gonna have to come back to that.
Okay.
That is crazy.
Now,
That is
you know what's
amazing.
interesting to note? Watch, wait, keep it going. Keep it going. Okay. This is the interesting thing to note, right? Look how much
Uh-huh.
more at the edges of it. Look how much, like, you remember how you were saying that the ether wind could be
Oh,
completely
it's like
faster?
a galaxy.
Yes. Yep.
Yeah, it's
Oh,
Oh
like
yeah,
the speed.
go back. Yeah. You saying
But,
the
like, remember-
outside spinning faster, of course.
The outside spinning faster, like we were saying. That's why the magnetic declination is so extreme at the southern parts of the world. Probably that makes a lot of sense.
But see,
What's
galaxies
that's-
are not a bunch of suns, right? We don't know what they are, but it looks like it's electric.
Do
100.
you know if that's direct current or alternating current?
It's just a
If it was alternating current, it'd have to be really low.
So if you see, that's the magnet right there, the circular magnet, right? And he's just got a flow. Looks like just it's grounded by what is that? Just some type of glass or filament or something.
It's foil.
It's just
But
foil.
the ground is on the outside. See the little clip on the top left?
Right. So
So
the
there's
ground
probably
is
a little
the
bit of salt.
outside. So check this out. If that's the case, right? What if the ground is actually the firmament?
What?
Yeah.
How dare you?
Check it out though. Hear me out for a second.
All right, I'm listening.
The firmament would it just based off of that, what I just saw right there, the ground would actually be the firmament, right? That would be the outer edges. That would be the ground part, right? Then you would have the flow right there in the center part, and it's actually what we're seeing when it comes to like lightning, right? Like how they say that the ground gets its they say it gets its ground from the lightning. But I don't think that's the case. I think they get the ground from the entire whatever the fuck we're encased in.
Yeah, the enclosure is the ground, just like it would be on an actual electrical device, right? You can enclose it you could ground it
Exactly,
to
the chassis.
Yeah, like the chassis would be the ground.
Right.
So you're saying that the firmament, and where it comes down and touches the ground, like on the outside of the Earth, is like the ground, and then the center pole is like the hot wire.
Yeah.
Oh man.
Yeah, essentially.
Yo, so are you familiar with like solar luminescence? Do we just like live inside of one of those?
Yeah, solar
Yes.
luminescence, bro. Yeah.
Are you
that
saying
just-
we just live in a bubble, bro? Bubble.
Crazy.
Right,
I
because
mean,
there's water
it's
up there.
possible. Well, you've seen sonoluminescence, right?
Yeah,
Piezo?
bro.
Yeah, Star in a Jar.
Yeah.
You guys all have seen Star in a Jar, right? Anyone here who hasn't seen Star in a Jar?
What if the? Yeah, I mean, like that would imply that the firmament is indeed a solid object as well, because we'd be like an eggshell or like a snow globe that's actually like physical on the outside holding us in. But instead of being water on the inside of the snow globe and the atmosphere outside, it's atmosphere on the inside of the snow globe and water outside.
Let me ask this just for clarification. If we can see the top, like basically the top hemisphere, and then we are on the block domain wall, would the firmament above and below be ground, or where does the polarity change? And what's the block domain wall if it's all sort of connected in like the same powerful system?
I think there has to be a differential between the sky and the ground. Like maybe they're connected in some way. But and actually maybe there'd be, if that were the case, then it would be, I mean, something's causing what seems to me to be some kind of like a direct current, like from sky to ground. Well, there is a current. There's a measurable current. So either that current would have to somehow like dissipate as you went to the edges, or you'd have to have the surfaces be separated, I think, essentially. But no, that's actually not true. There could definitely be like a full circuit that's connected in some way, shape, or form outside of our realm.
Hey,
But
um,
sorry, what was the original question?
the original question is, I was wondering like where would the polarity differences be if there was like a as above so below. If we're on the domain wall in the middle, and there's a sphere above us that we can see in the firmament above, but there's also a firmament that goes all the way down and around in the waters below the great deep. I just wonder what's positive and what's ground in the whole system, not just because like right now we're trying to flip our ground that we stand on from ground to be in the firmament's ground. But then I'm thinking of like the whole toroidal field and how would it have different polarities. But that thought's already sort of passing. I want to add in one more thing, and y'all can touch on whichever you want. But think about the waters, all the waters of the ocean butting up to the ice wall, butting up to the potential firmament that goes up and above. But there's water above too. And you were just talking about sonoluminescence, and is that just a high intensity of sound? Because if you think about all the stars in the superfluid above, what would that do to the environment of the firmament, electrically, or if we're talking about polarity?
All right, I'm gonna ask you guys. I hope that you know about the Casimir effect. I've been talking about it for a long time, and the quantum prediction that just came true, or they just proved it to be true, the Schwinger effect. If you haven't read either one of these articles, you might find it interesting. But imagine the Earth and whatever's above us in the sky as being two plates instead of a dome, right? Because we don't really think that it's a dome, right? What if it's two plates? The land and the ocean is the bottom plate, and the top plate is the sky, what we call the firmament, right? It's described as like expanded out, like stretched out brass, like a shield, right? So if we live in a model that looks more like the Casimir effect, I think that would explain kind of what's going on here, why there's always so much, electric dynamic activity going on in the sky. People have seen Foo Fighters, orbs of light over Mexico, all sorts of, things in the sky and the ancient paintings all back in the day. All these things are electromagnetic, in my opinion. They're plasmoids, right? And when you see lightning, it's plasma, right? You're looking at plasma. And I think that if you kind of think about the world like this, it really makes sense. So if you just take this Casimir effect and turn it on its side, I kind of think that's more like what we live in. Thanks. Oh, and the counter space is the dielectric, right? That's what holds magnetic, electrostatic fields, whereas electricity holds in the metal plates, right? But the space between the counter space, between the two plates, that's where the static field is.
Where
And
we live.
that's where we live.
Got it. No, that makes a lot more sense. Shit.
And that's where we get that number with 120 zeros that debunks Einstein's cosmological constant. That's why there's a crisis. Thanks. That pesky vacuum energy catastrophe.
It was a catastrophe, you say?
Yeah, for the Einsteiners.
There's always a cosmological horror going on up there, according to them.
Yeah, that's why they give us so much horror back. One day the sun's going to explode, or it might just go out. Either way, it's going to be terrible. And we might get hit by a meteorite. Stand by. It's always, Cthulhu from the sky, he's coming. You're going to get attacked. Something bad's going to happen,
Yeah. Yo, Toby, can you go back to the owl, please? Or did you you didn't go over that already, did you?
The what?
The owl, the what do you call it? The
Magneto-kinetic.
Yeah, the magneto-kinetic dielectric potential picture. Sorry.
Actually, let me pull up the. There's another one too. Let me pull up the actual Steinmetz book. Where are you, Mr. Steinmetz? Here we go.
I bet he was really good at hide and seek back in his day.
Steinmetz. Okay. Electrical field of a conductor.
The magnetic field consists of eccentric circles surrounding the conductors, as shown by the lines drawn in Figure 9.
So what does
An
it say?
electrostatic, or as more properly called, dielectric field, issues from the conductors. That is, a dielectric flux passes between the conductors, which is measured by the number of lines of dielectric force. With a single conductor, the lines of dielectric force are radial straight lines, as shown in the dotted line in Figure 8.
And that's the dotted lines.
Yep. Which would be the iron filings on a bar magnet.
Okay.
As seen, the capacity current is the exact analogy with regard to the dielectric field of the inductance voltage with regard to the magnetic field. The representations in the electric current or the electric circuit of the energy storage in the field.
What's it say right there? Unfortunately?
Fortunately, to a large extent, in dealing with the dielectric fields in prehistoric conception of the electrostatic charge on the conductor still exists, and by its use destroys the analogy between the two components of the electric field, the magnetic and the dielectric, and makes the consideration of dielectric fields unnecessarily complicated.
I remember that quote. Yeah. Dielectric field intensity, dielectric density.
The actual gradient in a uniform field in that between two conductors varies, higher at the denser and lower at the less dense portion of the field. Then is the dielectric field intensity, which would be the dielectric density.
Where K is a wait. Where K is a constant of the material. So the dielectric density is the constant of the material. So essentially, permittivity. Okay, so the constant, so the electrostatic permittivity of the atmos. Because that would be a constant, wouldn't it?
Yeah.
That would be the capacity. And then the permeability would be the motion, the back and forth.
Or you're saying permeability? You said permittivity first, right? Sorry.
Mm-hmm.
Sorry. Okay. Cool. Yeah.
So what's permeability again? That would be
magnets. Fast a magnetic field can move through a media.
the permeability. Okay.
Oh, so the magnetic field is like much slower than light, I'm guessing?
Depends on the
No.
medium, right? Magnetic field is basically light, invisible light.
Well, it's
But
like
they say that light is electromagnetic radiation. QE doesn't think that,
but if something's magnetic permeability and electric permittivity were different, wouldn't the like light and magnetism move through it at different speeds at the same time?
It would reduce the overall speed of it, like in general. Like it can't be both, right?
That's what I'm saying. You would test it like that and see, right? Like have a magnetic wave detector and a electromagnetic wave detector at the other end and fire them simultaneously. Experiment idea. Bam. And you would have a known constant for the permittivity and the permeability for the material before you did the test, right? You'd measure those first. So
The hysteresis or the hysteresis cycle. The fuck is that? I gotta look that shit up.
Same.
No wonder they're teaching us about Einstein. They don't want us knowing shit about this.
Ah.
Let's
Get the
ask old
fuck out of here, bro. Literally, what did you say? That it'll slow down? Hysteresis, the phenomenon in which the value of a physical property lags behind changes in the effect causing it. As for instance, when magnetic induction lags behind the magnetizing force. Like the moon.
So the magnetic wave is going slower than the light wave? Or I mean, because the light from the moon goes by a lot faster than the magnetic force,
What
right?
if the moon, right? What if the moon is actually a hysteresis effect that we're witnessing? That'd be interesting as fuck. Sorry, I'm kind of going deep.
The system
hypotheticals.
depends not only on its current conditions, but also its past history. It's most commonly discussed in the context of magnetic materials, but can also apply to other areas such as mechanical systems, electronics, and thermodynamics. A hysteresis cycle is observed when the material is subjected to a changing magnetic field. The magnetization of the material does not immediately follow the applied magnetic field, but lags behind it. As a result, the magnetization versus magnetic field graph forms a loop known as the hysteresis loop, or hysteresis, yeah. The loop is a graphical representation of the energy loss per cycle due to the magnetic material's resistance to changes in magnetization. In other systems, hysteresis can refer to similar lagging effects. For instance, in mechanical systems under cyclic loading, material deformation might show a hysteresis cycle as the stress and strain do not follow the same path during loading and unloading. Similarly, in thermodynamics, systems like phase transitions can exhibit hysteresis, where the transition temperature depends on whether the system is being heated or cooled. Interesting. So it's kind of more, it's like a... I mean, I wonder if it would create like an impulse cycle, or not like an impulse cycle, but it would create like a... Really, it would create like a... an ever-changing geometric cycle. So actually, like in a toroidal sphere, in the way that we envision a lot of the stars and like the cosmos moving, I think it makes a lot of sense.
Yo,
like,
check it out.
Like a cycle within the cycle, right?
Ask if hysteresis or hysteresis affects the speed of light.
Greetings from the Man of Stone.
Hello?
You guys can hear me in there?
It's Stone Man. What's up?
Hey, gang. I think I can help with this subject a little bit if you got the time.
Absolutely, brother.
Awesome. The term is indeed hysteresis, and it's something that I've been going up against for... Oh, wow, the stream just ended.
What happened?
Is that all right?
Yeah, I figured. I mean, if you want, I can pull it back up. I figured we'd rather listen to you than Chat GPT, so I just minimized my screen.
I'm really cool with actually just leaving that definition up.
Cool.
That's
okay.
That's kind of helpful. Sure. Yeah. Thanks, Toby.
Thanks for popping in, man.
I'm just making sure everybody can hear me. I mean, right now I have Q bound to my mic, so I'm just kind of sitting here staring. But the hysteresis thing, in the context of where I've been busy for the last 25 years almost, has to do with motor building and the core materials that you might be using. This is the same phenomenon, and I'll deal with why, that they ended up changing motor design, even way back into the Tesla end. And you hear it when we we talk about his competitors, it has to do with the core material itself and the AC function. That when we apply a polarity in one direction across the metal, we're magnetizing it in a particular direction with the dielectric that you guys have been mentioning. That is the battery or whatever that is going to be driving your motor. What that's doing is inducing a charge, so to speak, across the material itself as the flux is created. The hysteresis is a resistance to being magnetized as well as being demagnetized in an AC scenario. That when they apply the polarity in the opposite direction, not only is the material demagnetizing from what you just hit it with, you have to remagnetize it with the other polar state. And what you're looking at are two different curves, rate of induction of the polar state you're getting into the material, the core material, and the rate at which it demagnetizes, so to speak. And they are they're different. When you deal, I don't deal with, when you listen to guys like Eric Dollard, he spends a lot of time paying attention to that and how the guys in the old days, about 115 years ago, resolved that. And what they did was they figured out that they want to create laminations in the core. What this does is essentially focus the direction along the material itself as it magnetizes and demagnetizes. And the reason that they do that is so that it can happen more quickly with less material per unit slice of the core, if you will, being exposed to that particular magnetic force or dielectric force, right? There's a gradient there. So that what I found is that when you use a frequency, an AC frequency, or your motor is going too fast, you develop heat. And it is the resistance of the core material to magnetize and then demagnetize at a rate higher than it is comfortable to do. You create what they call eddy currents, but really that's internal friction by combative polarities, if you will.
Wow.
This is where the hysteresis effect comes into play.
Wow. Thank
Wild.
you
You guys got
so
that?
much. That's super fascinating. It makes a lot of sense too.
So,
So
can I ask you? Okay, so you said that they figured out laminations in the core. What does that mean?
what that means is instead of a solid piece of chunk of metal, you got
Right.
slices, and they are electrically isolated from each other. When they make transformer cores, are you guys up on the goop that they use?
No.
No.
Okay, it's basically a clear liquid. It's the same polyester or whatever high temperature capable stuff that they might use to insulate the wire to begin with, even
Okay,
on the way
gotcha.
into the core.
So they
right?
slice up the core, slice, insulate it with this fucking goop, and then that way
Yeah.
you have less of a hysteresis effect on the material, the core, essentially.
So it's like a
Yeah,
lacquer.
the hysteretic effect in what you see in terms of heat is coming down with respect to the same frequency at which you are polarizing and depolarizing it, with AC. So yeah, essentially, you're totally on it. That because you're hitting a smaller net mass with the same force or the same voltage or the same rate of induction, magnetic polarization, however you want to look at it, that it's because it's happening to a much smaller piece of the core material, it is able to operate at higher frequencies. And as far as I found, they've never really got above 5 kilohertz. That steel and Chinesium and whatever any in between kind of material that they use to build transformer cores with.
Chinesium. I've never heard that before.
Yeah, like,
I had to say.
there's a definite upward limit there, and it actually has to do with the Curie point in a ferric material. Are you guys up to date
yeah.
on how they magnetize something? When you create a magnet, it's done within a field where they heat up the metal and then cool the metal in the presence of the field. That's how you create the polarity and the magnetic moment in the material.
Huh.
So what we're doing is we're relating
So
that to the core. And we're saying that, okay, we've got steel that was not cured or cooled when it was formed in any other kind of magnetic field other than Earth's. So that within it, the force of the magnetic field that we experience, like what you see on your compass, that takes the arm forever to go over to point to north because the field is so weak, comparatively, that the material itself isn't necessarily aligned with north, so to speak, as it cools below the Curie point. So what they've done is they create what is called an amorphous metal. And yet it doesn't even actually have to be completely ferric. They're adding silicon, titanium, and other magnetizable materials that happen to have different magnetizable rates. No, that's just to complicate the situation. And what they create is called met glass or amorphous metal. And back in the early 2000s, the late 90s, when I was trying to get a hold of that stuff is like unobtainium back then. Now it's just like off the shelf, like a supercapacitor. You know, I think I just spin my head at how much easier things are to build in this decade. But that's really what's the in and out, I guess, for the hysteretic effect. Any other questions? Fire 'em at me.
Yeah. So going back to what you said, they'll take some not magnetized metal, melt it past its Curie point, recool it in some type of magnetized field, and get it and actually make it magnetic. Is that what I heard?
Thank you for reminding me. I didn't actually cover that. No, it's about the rate of cooling past the Curie point that that changes the nature of the metal itself. That allows it to magnetize and demagnetize at much faster rates. Yeah. It's the speed at which they drop the temperature as it forms down past the Curie point again as it cools that gives it the amorphous finger quotes amorphous quality that allows it to magnetize and especially demagnetize at way higher frequencies.
And then that gives it its usability in things that are oscillating back and forth between each other really fast in alternating current.
What they say is that it serves to reduce hysteretic loss. And when they say loss, that was the heat I was talking about. That when they talk about magnetic permittivity, again, this is the same thing, just using a different term. And it is a rate, just like the induction rate of a B field inside of a core, just like the induction rate of the perturbation of ether when you generate a light or a light frequency oriented piece of EMF through space. You know, everything we've been talking about light, that it's not particles, that's the fantasy, and Ken Wheeler's all over that. But it's, when we talk about it, it's all about induction rate. Nobody on the Globe side, of course, will talk about induction of what. That's the comedy, right? But I can hear Alan chuckling. But
what's being induced?
That's really the game. That's the game right there, isn't it? What are you inducing? So I wanted to cut back a chapter to when Toby was starting out and showing you the Steinmetz stuff, where you've got two conductors coming in and out of the page, and that is a cross section that you're looking at of the conductor. When you see the two little black circles in the middle of that figure 9 diagram we were looking at. Okay, where am I? I was going somewhere with this before I got into nomenclature.
Hold on, he's going to pull it up for you.
You're saying that's the
sure.
Something point. You said that's the something point between the two conductors.
Oh God, I call it a brain fart. I had a perfectly beautiful idea forming, and then it just went out into nowheresville. Give me one more sec staring at that diagram, and it just might come back to me here.
Well, it went out into ether. It'll come back.
We talk about
exactly. The perturbation is not quite finished.
All this shit's fucking fascinating to me, by the way. I'm still like a newbie in this field. So
it was having to do with Steinmetz. You said Steinmetz when Toby started out.
Thank you. And it's where to put it. I wanted to get back to identifying the difference between these solid lines and these dotted lines in Figure 9, and talking about all this potential and all this pressure. But really, it's really hard to mentally conceive of magnetic or kinetic pressure. How do you manifest that in your own mind in a tangible way? And don't even try is the point. Okay, so we're looking at here are, when they say conjugate, what they mean are separated by perpendicularity. And that's what we're witnessing on this.
Separated by perpendicularity.
Mm-hmm.
Yes,
That
they're
it's all about this 90
always
degree thing.
perpendicular.
Yes, that when the electrical flux, or the current in this case, is coming in and out of the page through those conductors, that is because of the dielectric. It's not really potential tension, and I think that's a cool relation to in Latin America, which is where I live now. Voltage translates as pressure. So let's back it up even one more, and we'll just talk about the concept of where to put it. And it is voltage. It is energy. It is the capacity to do work. These things that we've been intangibles we've been talking about forever here, is where to put it. And it turns out, because of this perpendicularity that I'm pointing out, we're only talking about two places, and we're only talking about two mechanisms. This is why the Faraday cage has no effect against the other. That a Faraday cage is really EMF transmission blocker, and the size of the mesh that you use relates to the size of frequency spreads that you want to dampen or ground, or however you want to think of that, trap them out of the air. And we can talk a lot more about who's the guy? I even make them myself, but I can't remember the term. I'm sitting, they're right here under my feet.
Grounding mats?
No, they're holy hand grenades. Oh God
He's
damn it.
electro.
No, they're a passive device. You pour them in 2-part epoxy, and they take
Organite?
the scalar. Thank you, Organite. They take the scalar out
Okay.
of the air, right?
Ding,
That's
ding, ding.
thank you. Points to you. Okay, so now back to the theme of where to put it. It's that thing. It is that energy, that scalar, that capacity. Where are we putting it? Okay, well, there are two physical things in the electronic world, in the power electrical world, that we use as a civilization. And it's all about where to put it. One is between two Gaussian surfaces. The other is inside a cylindrically shaped coil, or a toroidally shaped coil, because that's essentially an unending cylinder, right?
An unending cylinder.
They are actually the two types of forces, capacities, conjugate entities. This is the where to put it thing. That when we talk about voltage, like electricity, the way that we think of it is actually created or manipulated in two ways. One, electrostatically, like a capacitor, where there's a plate here and a plate there, and one of them is essentially, quote, ground at 0 volts, where there's no potential to do any work at all, and the other one is positive, or there is integer-wise, psychologically positive capacity to do work. This is what the dielectric potential, though every time they speak of it, is really about. It's just about where to put it. And in a capacitor, that's where you're putting it, in space, in ether, in the area between those two plates. That's the voltage stored between them. Well, the same thing is going on with the magnetic component in induction, and they measure it in henries with coils. That when you look at a cylinder and this is the same thing you do with your hand, with your thumb poking out the end, and your fingers are the flux, and the right hand wheeled rule, and how they construct that has all to do with this same thing. We've been talking about the rate of induction in a transformer core. Well, there's a coil wrapped around that doing the work. That is the other kind of where to put it. That is the B field that is created when we run flux or dielectric current through the coil itself. And its own resistive problems create heat in the coil, because you're using copper instead of silver or aluminum or something, which is at the top of the list of extremely conductive, low resistive metals. And we use the term metals loosely there. You know what I mean? Am I making some sense?
Yeah.
Yeah.
You're wowing us. You're wowing us.
Yeah, we're all
Thank you
listening
so
very
much.
intently.
Thank you so much. I rarely get this kind of opportunity, and I watch you guys in the channel. If I was going to be a dick, I would say it reminds me of a movie, and it was The Life of Brian. One particular scene where they're chasing him around with a gourd and a sandal. Do you guys remember that scene?
Never seen it, but kind of familiar.
I love the movie, but I don't remember that scene for some reason.
I couldn't recommend more strongly a revisitation of that scene where Jesus, or Brian in this case, is running through town from the Horde, trying to escape them because they're all trying to worship him and take anything that he does as a sign. Oh, the gourd, we must worship this, we must worship that, and it reminds me of that when I see you guys trying so hard to comprehend things and come to an agreement about nomenclature. Even it just reminded me of that. That's all I'm saying there. I just thought it's really cool that there is.
So wait, are you Jesus in this scenario, or Brian?
no. I'm the guy on the side of the trail picking his nose.
Oh, I see. So you're watching us chase each other around.
I am definitely not following the crowd with a sandal in my hand. I'll say
I got
that.
Yeah, you're
Okay,
just
that's
it
as far
out.
as I'm going with that metaphor.
We're chasing. So wait, with the Christ figure in this scenario, or the
It's
mistaken
just
identity,
knowledge. It's
is
just
knowledge, right? Yeah,
Yeah,
right. Exactly. What I was gonna say.
exactly. What else would I talk about for Steinmetz? Okay, how about I delve into a little bit of my own work, which you may have seen some of. Get this cat off my lap. In some of my live stream stuff that up on my own channel. If you guys have traipsed over there,
Plug it. I'm not familiar.
I didn't know you live streamed, bro.
Only twice, and it's not like I had guests or anything. No, I had that on my very own channel. Quote, just as back then I had about 1,000 people, 1,100 people in there, and I figured it was a good opportunity right at the end of the EWAR phase, when people were finally breaking out and looking at energy, what was going on in Paris with Arc de Triomphe, and what could be hidden in that structure, because there are no architectural plans for public consumption of it. All far too conspicuous, in my opinion. I did a cute little video on what I thought they should stick in there and hide in there, in terms of coil action, too.
My familiarity with that Arc de Triomphe interpretation of EWARs was that it was like a horseshoe magnet, right? So it was the idea. And then there was another follow-up to that. There's a woman called Flat Water, I think, or Flat Out Truth, I think her name is. Anyway, so she did a whole series about gods. It's called Gods and Monsters, and interpretation of the Arc de Triomphe, as well as any of the other ones, especially the ones that have 3 arcs, is that they're placed specifically so that the summer solstice and the winter solstice and the Tropic of Cancer or Capricorn or wherever the center is, right? So it comes up through the middle, and then it comes up through the sides for the solstice risings of the sun, and so you see the sun right through the arc.
You
and that's
kind
the
of
reason
lost
they
me
put
on
them
that one. Can you get back just to the pegs on that? I'm not really sure what you're driving at.
She's saying that they're placed on the Earth so that the sun
Which
is centered.
No, I mean right back to number one.
The Arc de Triomphe, as well as the other arcs. There's arcs all over, and
okay, they're functioning.
So they're placed so that the sun is centered in the arc, so they know what time of year it is.
I get you. Okay.
Yeah, and that's why that she was talking about how they moved one of them without even thinking about that. They just weren't even aware of that being like a decoration. They decided to move, miscellaneously to somewhere else. It didn't make any sense to move because the sun wouldn't be there.
But what happened to the unit when they reoriented it?
I think that they were that was the one she was talking about that they did in New York. And they were having to do with the centering of the World Trade Center, and before it was blown up, and the black box that was also centered in between the two. Anyway, that's an interesting series, but I don't want to get away from your point that you were talking about with the arc and what your interpretation was.
That does sound like a pretty big digression, but hey, probably worthy of pursuit to even look at. I have always been fascinated with Masonic building placement. Yeah,
Yep.
indeed.
For sure. But what were you going to say? Because I know you are talked about it as she was like some of her work, and so it was interesting because her interpretation wasn't that it was meant as like a horseshoe magnet, like a power source, which is kind of where he was leading with it, and he never did a follow up to like as far as I know that was kind of like acknowledging her interpretation of the reason they were built rather than the horseshoe magnet idea, which I don't know if that's ever been even explored. But
I don't think it
or
has.
what's your
Well, I don't see the arc as a power source. With the video that I put together, I kind of more saw a transformer function there because
okay.
we've already got the buildings for the source. You know what I mean? We know where the voltage gradient exists. And I also recommend people take a look at the pictures I posted again on my very own channel. You'll see a folder of pictures I uploaded when I was in Paris about 18 years ago or whatever, and I went over to Notre Dame and didn't take the tour. I, however, did climb the stairs and went up to the top's front center on the building itself, where you get a really good look at how that building's exterior has been modified in so many ways. And they did not cover up their work. Let's just put it that way. Everything from different grades of mortar to types of caps that are put along the tops of edges of the rooftop that have completely been changed. Things that are on the walls there, like the many figures that you see up there. You learn immediately when you look at them that the gargoyles are second generation. The demons are second generation. There are other characters up there too, and you see the workmanship difference between them starkly. So on top of that,
are you talking Tartaria type stuff?
Yeah, very much in that direction. Previous civilization. I'm not happy with the label, but it's definitely definitely previous to our understanding of our own civilization. And what is most striking that I noticed up there, after I looked at my own pictures again, after watching all of Ewar's work, was that the little light bulb fixtures are all still up there, along with the conduit that is in the wall itself. And it is in the form of steel banding, if you will, because I don't think they're copper, and they had to make them really big and wide to reduce the resistance through the conduit itself, just to improve overall efficiency of light distribution across the whole structure, right? And so yes, by all means, go and check out my little tour. I wrote up a couple hundred words to fly you through it and just kind of cover what you're seeing in the pictures when you see them.
Did you put a link, or is your name Man of Stone on YouTube?
Oh yeah, it's actually all on Telegram. If you're in the Miswits channel, you can just in Telegram you can just find me in the Miswits channel and do a search by just me, if you know what I mean. Like you can hit the magnifying glass, but then hit the people icon and pick me as a user and go through my posts, and you will see countless references to both the Stone Cold Truth channel, which is an invite link, as well as my very own channel, which is another invite link. And on the former, when you join, make sure that you click on the button, the big wide button that we tack on to the bottom of the list of rules that pops up as you join the Stone Cold Truth channel. And you have to click accept the guidelines within 3 minutes, or my bot will assume you're a bot and ban you. So that's the heads up for the SET channel. The other one requires no such thing because it's actually there's no chatting going on there. It's just a poster, really, of stuff that I've done. And that's what I kind of wanted to go into at one point. But before then, let's stay more current. And I wanted to handle a couple of comments about when Toby was covering lightning. You guys up for that?
Yeah, absolutely.
As long as everybody's still there, cool. And yeah, okay. First off, the unit of measurement is coulomb. just to be a dick, I had to point it out. Yeah, it's just, when people are new to the art, so to speak, when they're not quite fully skilled in the art, these are the things that you just look at on the page and it's like, what the hell? But eventually you watch another 500 videos about it and you figure out what the terms are, right? Same with adiabatic cooling. It's, you've either been there so far or you have yet to be there. It's just we all walk the path. It's just a question of where you are on the path, right? So with the lightning thing, I've there are a couple of different um, so I noticed kind of things I just wanted to point out when we were listening to Toby cover it, and he pulls up the big diagram of upper elevational forms that lightning takes, and the colors, how the ghosts resemble the same color spread as what you would see at the polar, at the aurora, and that kind of thing. Firstly, let's talk about shape. That when we're down here on the surface, we look at lightning, we see the same kinds of things that we see at power stations when they pull the conductor. We see that massive forking, right? That is because of the density of the air and the air quality itself. Again, this is a bit of the mechanism behind what causes lightning, is what's in the air just before lightning strikes. And let's back it up even one more step. What the hell is lightning? You're right. It's the Gaussian surface way above us, constantly holding charge. And we are witnessing the catastrophic breakdown of a capacitor in the form of an arc. It's the same thing we see at the micro scale with a little cap in our hand when we put too much voltage in it and it blows. There's literally lightning going on from one plate to the other. And really all that we're seeing there is what the globies call an electron. And an electron, when you see it in free space like that, signifies nothing more than the resolution of charge to ground. It is the extinguishment, if you will, of charge itself. And charge, the way we look at that macroscopically, charge, again, like we talk about capacity and energy, what the hell is charge? Charge is something that has a voltage potential and is seeking ground. This is why we use insulators, because we want to prevent it seeking ground until we're ready to use that to our own advantage as power or whatever it's going to be, right? In this case, it's an instantaneous grounding, an instantaneous catastrophic failure of the Earth functioning as a capacitor. It's being overdriven from the top, so to speak, beyond its rating, its voltage rating. Like here we handle caps in consumer electronics with voltage ratings of 10, 16, 50, 100, 200, 400 volts. Well, the Earth capacitor is a 500 million volt rated cap. But there's more than that above it, constantly charging the top Gaussian surface, and it is constantly catastrophically failing and arcing to the ground. And this is what we see underneath it, inside it. So why do we see the forks is the question. Well, first off, we understand what's in the air itself, that it's more dense than what's above. It has more particulates in it, necessarily, because it's more dense, and it's closer to us dirty scumbags on the surface. All this crap coming out of our buildings and our businesses and our industry and our cars and everything else, that's all in the air. And the more of it that is in the air, the more you're going to see lightning, because it is the particulates that form the trail of these arcs. And if there is no clear trail to the ground, the potential itself starts to fire out sideways in the form of those forks, looking for an alternate ground. And the reason that lightning looks different as you go up, it's just a function of air density or lack thereof. That the lightning forks don't go out sideways anymore because there's nothing there to grab onto or look through, if you know what I mean there. That the lightning looks far more milky and vertical and dignified, if you will, as you go higher and higher and higher. And again, just at the top, the final point I wanted to make there is about the color. That this is the same thing that we witness in the difference between sunlight and daylight. That sunlight is direct radiative, from the source itself. Daylight is secondary, where that same radiation is hitting rarefied gases because they only exist in abundance at lower densities, which is only in upper atmosphere. That's what produces daylight. That's just being near the sun and ionizing, right? Well, the same thing is going on when you run lightning through that gas. It turns that color because that's the type of gas through which it's arcing. It's catastrophically failing. Did I get you guys on that one? Is that cool?
No, yeah, fantastic. Actually, I had meant to touch on that and I didn't. Yeah, fantastic.
My absolute pleasure. So, yeah, but any questions come to mind on any of that stuff? Should we cover that?
Is there any electrostatic discharge that's not dendritic in form?
Atmospherically speaking?
Yeah. Like terrestrially speaking, yeah.
Not without another conductor, not without the presence of another conductor. It's going to be stratified just the way that we see the stratification of the equipotential voltage lines of the force itself coming upward positively from the ground. It's the same kind of thing that if there's nothing in between the top and the bottom, there's no motivation to go in that direction to seek an alternate path. So the
Right.
dendritic the
Have you ever,
dendritic nature that you're citing there is strictly a function of air quality, humidity, and peaks of the ground proximity. You know what I mean? What's in the air and how close the ground is to up. Oh, lightning rods. I did
Right.
want to cover that because it's something a buddy of mine who lives in Ghana, who hangs out on the SCT channel. He used to do a fair bit of moderating for us there too. He's a ex-uni student. Okay, there's the brain fart. It was a guy in Ghana. I was talking to him about something, and we just covered lightning. Lightning rods. Thanks, Alan. Yes, he asked me about strategy for what do you do about keeping lightning away from your house, and he pulled up 125-year-old articles, examples, kind of thing, inventions even, of people who would put a big tall rod on their house way up high and attach it to something that's thick enough that won't vaporize when you run 400,000 volts through it instantaneously. And that's a good way to protect yourself from lightning strike, when in fact it's the opposite. You're creating a waveguide, so to speak. You're creating that path that those forks are seeking. You know what I mean? By sticking one way up in the air with low resistance, that it's a metal, right? That it's a solid conductive metal. The charge potential sees that as a free meal.
Yeah, just a spot to jump.
It ups the frequency of lightning hitting your house, right?
Have you ever seen videos when the charge potential is high within a said proximity of people and how their hair starts to react to it?
I sure do.
And,
exactly. Those are the same dielectric lines of force you see in Figure 9.
Oh, you got pictures up?
No, you had them. Toby had Figure 9 up that we were looking at with the two conductors in and out of the page. Those dotted lines are what is interacting with the hair in free space between the charged conductor, which is held with a certain capacitance, and the hair, which is on the way to the ground.
That makes a thank you. That was a great visualization of the electric lines of force, dielectric lines of force. Thank you. God damn. Okay, dude, awesome. Starting to make sense now. I'm getting the owl. I'm getting the owls now, boys. Okay.
Perfect.
Oh, you're starting to understand the owl eyes?
Yeah.
Well, yeah, you got to understand the conjugate geometry of the dielectric field, and as it loses its potential, that's what breeds the magnetic field, and it's this reciprocating geometry between the toroid and the hyperboloid, and and that's within everything, right? Like that whole geometry is
Almost.
throughout. Yeah, it's throughout.
Almost 100% on that. That when the flux is occurring in the moment of the dielectric change in charge, as in we are driving voltage through the conductor, that is when the magnetism is created. It is the flux that creates the magnetism. In the same way that induction happens in a coil.
Yeah, but the thing is a magnetic field doesn't have any flux at the center of the magnetic field, because that's where it's coming from, the dielectric field. So they're always in tandem.
I'd be happier if you referred to the B field, because that's really what's happening in the case of an electromagnetically inducted field. That it's not a magnetic field; it's a B field, and I find them to be quite different. And it is actually the B field that I wanted to address in my next tirade about what I was doing starting 25 years ago and trying to build a better motor, so to speak.
When you say the B field, is this like another image that you're referring to, or is this just like what you're?
No, that's right back to the right-hand rule and the formula F equals BIL.
Yes.
I mean, I remember that from grade 9, early 80s for me.
Is there any?
Oh, that's a hard question, because I haven't met all of nature. I don't know about that.
According to Walter Lewin,
when we talk about charge, right? That's universal. There's frankly, again, I look at so much of this Globy produced propaganda about physics, and Toby's presentation was delightfully full of it. That there's so much talk about negative charge. It's mind-boggling. And I've actually another Discord stream a couple nights ago, maybe a week ago or something like that. It was effectively handled. Somebody in your gang here mentioned that there's no such thing as negative charge. It's really about reference, and think of it as a voltage reference frame, if you will, in the same kinematic way you do with Einstein and moving bodies. That charge itself, maybe there is no such thing as a zero electric potential in terms of the electrostatic scene in which we live. That maybe because, I mean, you can dig a hole 800 feet deep and things will still drop into it. The electrostatic force is still there. You know what I mean?
It's not like
rule. It doesn't end where your toes are, is what I'm kind of drive at. What was that?
Sorry. Isn't the right hand rule is this describes where the current goes. That's why the thumb is sticking up. You can see the fingers rotate one way, and that's where the thumb is sticking up. That's the flow of the current. That's what the right hand rule means.
The flow of the current is represented through your fingers, actually, in the direction your fingernails are pointing and around. And the thumb out the end is the B field, what we're talking about there. And all that diagram does is establish the mechanism by which we determine polarity of the B field. That one's north and one's south coming out of each end of the coil. And it's a convention. It's nothing more than that. And that's why we have a problem with everybody in the UK with the left-hand rule. That it's a convention. It's how do they see the resolution of charge and which way does it go. This is why some people say, oh yes, lightning happens upward from the ground. Oh no, it doesn't. It happens downward from the cloud. Well, maybe it sometimes just happens cloud to cloud. Well, it doesn't matter. What you're seeing there is just where the charge extinguishes first in the resolution of the charge itself.
Yo, Stone, we were reading something, what was it, yesterday, from this old school book from like 1837 or something, that talked about lightning in clouds, in storm clouds, and how you could observe storm clouds float across the sky and bump into each other. And when they collided with each other, it like squeezed them, and it squeezed the electricity out and caused lightning to happen.
I like it. That's kind of cute. What you're really seeing there is just an increase in density in the air locally there through a heat function caused by the sun, right? Where one place where there was some convective heating seems to have been pushed into another place where there was some more convective heating. You have a higher concentration of condensation nuclei in the air in general next to both of those perceived masses in the air when their mass is almost the same as the air around them anyways. And that is what is increasing the lack of resistivity, if you will, between the two Gaussian surfaces.
Hey, do you have any thoughts, Stone? Did you see my part about the cyclones and hurricanes?
I was just dicking with Discord when you were talking about that. I did notice trend that there's a west to east trend, that there's a clockwise trend in the northern, like the north of the equator. Is there anything else about that you wanted to get at?
Oh, well, so it's actually a counterclockwise trend in the northern side, and then a counterclockwise trend, or a clockwise trend, or sorry, it's counterclockwise in the north and then clockwise in the south. And so I was kind of wondering if my theory is that it could have something to do with either the etheric winds along the equator or specifically the motion of the sun and or moon that are causing some kind of an eddy current or an induction that goes in a counter-rotational motion to what the directionality of the sun. Do you have any thoughts on that?
Yeah, to me it looks like an oblique cross-section of figure 9. Now digest that for a second, because that was actually a very deep statement. You know, what we're looking at is polarity with respect to the North Pole as the governor. And this is something the globies are going to assumptively attribute causally using something as dumb as the Coriolis force. You know what I mean? Why it's geometrically obvious to them that it's counterclockwise north of the equator? Because somehow at the equator you're spinning faster, you're creating this tangential momentum imbalance radiatively from the pole, if you will. Am I making any sense there?
Yeah.
Okay, cool. That that there is an ambient polar nature to how we experience polarity, magnetic polarity on the surface. And again, this is something we see in the magnetic declination chart as quadrature looking as it may come out.
You ever heard of inverse magnetic vortex polarities?
Inverse magnetic vortex polarities. Nope, never heard of that. Does that have to do with the decay of the field itself?
Basically, all magnets have an inverse spin vortex respective to one another, but face on are moving the same direction. So, if you were to take like an extrapolation of the force vector of magnetism itself, you could see like within the cathode tube twisting, the projected straight grid inverse spin vortex formations.
Oh, I see. So we're talking about vortexual motion along the lines of force themselves.
Right.
I get you. Okay. No, I haven't studied that too much, but I'm seeing how you're seeing it. That's totally, yeah, intuitive. That does fit. And I don't even want to use the word model, but it fits observation. Yeah, for sure. So let's address that for a sec and move on to what I was talking about, where what I was doing a couple decades ago, building more efficient motor mechanisms. For me, it was about this hysteretic problem that kind of revealed itself as the solution as well. When we're talking about how to use magnets, solid magnets, to your advantage in motor design. And are you guys up on AC motors and how they use self-exciting coils?
No, not particularly. Give me a quick rundown if you can.
Okay. Well, in a lot of the cheap DC motors, you've got all of these little, even the haptic motors in your phone. That's an interaction between
motor.
Yeah, I think you're lagging, Dice Low. He was just talking.
Yeah, you're breaking up there. Try it again.
Really just
10-9, Dice Low.
I think he lagged out. You're good, bro. Go ahead.
Okay, not to worry. But again, back to the hysteretic problem that I was trying to deal with back then. What I noticed about the B field in the coil itself, and this is, again, it's something they teach you in class, and when they teach it to you, they teach you it's a bad thing. That when you charge a coil and your thumb is the north, you know what I mean, sticking out of the coil, it's doing its thing. There's blood flowing through your fingers, so there's a B field coming out through your thumb. That's the on phase, so to speak, of this coil. You know, there is energy stored within the space across the core, which is why they put material in there. They want to amplify that. But anyways, at the initiation of the off phase, when the flux through your fingers ceases, at that very moment, the polarity inside the coil flips the other way for an infinitely short length of time at an infinite voltage in that opposite direction. And they just call it a spike in electric engineering. They just say, well, you know what you do with that? Since it's not the polarity we set up to play with anyways, here's a diode, here's a resistor, here's a path to ground for it. They waste it. They get rid of it because that spike is tremendously damaging to conventional silicon-based electronics like IC production and those types of parts. That's why they say it's bad. But you see, I see the geometric truth of it when you look at it on the oscilloscope up close. That is something where when you add it up, if you guys understand the pure function of an oscilloscope, all it shows you is voltage over time. That's all it does. It does a lot of mathematical tricks with the waveform and shows you all kinds of interrelations with them, you know, in terms of an axis, even if you've got two different voltages playing across time at the same time, whatever. But that's all it shows. And for me, arithmetically, when I'm looking at that wave shape, I see energy freedom. I see it lining up right there, that there's an equation here for me between the on phase and the off phase in computation of the total amount of power that moves during each phase. In the on phase, you got a battery, you plugged it in the wall, you got solar, you got whatever it is, you got a voltage potential of yours that you're managing. Okay, call that the positive polarity side of the machine, the on phase. You're hitting that coil with that. That's the power you're spending. Okay, and we see that in terms of a square wave shape, typically, where the line goes from 0 up to whatever voltage you're hitting it with, and then across the screen while you've got the voltage turned on, and then off it goes back down towards 0, right? Well, that analysis only involves the amount of energy that you're putting into the machine. What also is going on during that moment of the off phase, at the initiation of it, when you're looking at near infinite voltage in the opposite polarity, the hysteretic effect and the rate of induction of the coil itself work to your physical advantage in producing a larger area on the graph that you're looking at on the oscilloscope, that it drops from 0 to a really negative value, goes way down, right? But it takes time to get back to 0. And if you compute the area of both of these, the first one, you're computing your voltage over time. That's watts, right? That's voltage given a given amperage over time. That's how many watts you're putting in. That's how many volts and amps per second you're running through the coil in the on phase. Well, in the off phase, when the B field flips, it also drives the current back the other way through the coil at nearly infinite voltage for a nearly infinitely short length of time. But when you look at it on the scope, What we're doing is we're calculating that same area in the negative between the zero and the almost infinite potential and the time it takes to come all the way back to zero. That is slowed down by two things. The nature of the core, if there is one, and a lot of the Steinmetz drawings, like the ones you guys are looking at, there is no core. It's an air core, so to speak. And that's what Earth is. Air is in between, right? Well, the other thing is, again, the inductive rate of the coil itself, how many turns it is made up of, so to speak. That the ether is doing work here. It's producing what we perceive as a negative voltage in reaction to the fact that the positive isn't there anymore. It's like the bolo bat. I came to this metaphor 20 years ago. You guys know what a bolo bat is? It's a standard paddle with a big string elastic on it, 3 feet long, and a hard rubber ball on the end. If you're hitting that and it's going off into the air and it's immediately coming back to the bat, but the only energy you spend in your wrist is the hit motion. You don't care what happens to it. In fact, your grip on it is even a little bit lighter than, because you don't need that when you're not actually hitting the ball with the paddle. You're only spending that energy for a little bit of on phase, if you will. And after you're done hitting it, the off phase, which is the elasticity of the ball and the velocity at which it hit the bat, is coming back and firing it off into space, right? And that's where the elastic pulls it back to you and you get to do it again. This is how we create cyclic function in anything in nature. So the design strategy for me was spend a little, get a lot. Find ways to take the negative polarity and stretch it out and give it somewhere to go where the direction that it goes doesn't destroy everything that it touches afterward. You know
It's a
what I mean?
massive.
And
You would
that's
describe
done
that as a
capacity.
massive impulse, right?
Exactly. It is an impulse. Yeah, that's exactly what it is. It's the ether, and it's essentially the thunder that you hear in a lightning strike, right? The lightning is going, it's occupying that physical airspace, and then it's not. What you're hearing is the air rushing in to fill the space. Gaseous expansion, explosively so, right? And it takes a long time for us to hear the whole thing because lightning's really tall. It went right up into the sky, 50,000 feet or whatever it did, to finally get to that surface 20 miles, 80 miles straight up. That's how far the lightning actually traveled. And we are hearing the resolution of the beginning of the off phase, where that column of charge is no longer physically occupying that space in the air, and air is rushing in to fill it and equalize in terms of pressure.
That's
so
awesome.
you're hearing that as the distance goes up and up and up. Now Mach is the thing that makes it take longer, because Mach is essentially the speed of sound at a given pressure, and it is fastest at the highest pressure down where we are. So we hear a big long lightning or a long thunder clap, so to speak, because it takes a lot longer for high elevation sound to get to us. Isn't that fun?
That's really cool.
Man, dude, this is awesome. Thank
Yeah,
you so
thank
much
you
for
so
all
much
this
for popping
information.
in.
Like, dude, so
I
much of
know,
what you're
right?
saying is just like making everything click and make sense.
It is my absolute pleasure. No, really, tons of fun. So what did I say that's not clear there? That's the question.
I think it would take hearing it all over again. Saying
I was just about to ask that.
Joe, my friend wants you to say it all again. He just got back.
Yeah.
How far back should I go?
Well, you started with the motor. I was going to ask if it wasn't just to do it all over again. How far did you get with the motor? And is it still something you're working on?
That is something I would definitely invite you guys to check out my live streams on my very own channel. And I do cover some of my work for that. And Bedini is the man to study ever since the 80s. John
Uh-huh.
Bedini, if you guys remember
Yeah.
him.
Yeah, the Bedini motor worked.
Absolutely.
That worked.
He was a groundbreaker, to say the least. That guy had intricate knowledge about the materials you use in capacitors. In fact, he used to make his own from scratch in his own little
Yeah, I've
lab.
done that too.
Like, what I would have given to hang out with that guy, looking with his hardware. Like, oh my God. Anyways, so I spent a
Have you seen
number of years.
the meter that he made?
Pardon?
Electric gravitational wave detector?
No, never did hear about that. That's trippy. Did
Yeah,
he
it
do
was
that
one
with
of-
Friedrich or on his own?
Oh, yeah, with Fredo, I believe.
Okay, that guy's a whole other chapter.
Mhm.
Holy moly. But yes, definitely check out the live stream. I mentioned Bedini a few times because really for me, it's about life purpose. And I got a hold of mine a while ago, let's just put it that way, that when I saw Dick Cheney, no less, in the late 90s. So again, this is before 9/11. Before he was vice president, he was dicking around, just getting busy with Halliburton and creating his cost plus financial strategies and such. He attended an energy conference in Toronto right about that time. And it's to set the scene here. California that year, the previous year, I guess, spent an extra $164 million on grid power that they bought from the Canadians. And they had a little problem trying to pay it back. So they had this conference, just sort of a spin-off thing. I don't think it was cause and effect. It's just something that happened afterward, fairly recently afterward. And Dick got up there, and of course he's one of the keynote guys. Everybody comes to hear what he has to say. God, the guy pissed me off. He rattled off first of all, he suggested what the energy future was going to look like for everybody on Earth and how it was vastly into the petrochemical end of the world. And he dismissed the, quote, pipe dreams of solar, geothermal, and others with a wave of the hand. Suchly that it made it even right into the newspaper article that I read on it. And that is one of the very few moments in my life where my own purpose became very clear, that this guy was hanging out with some very bad dudes that are not doing anything in human interest. And that I'm probably going to have to be one of the people to step in his way and create something disruptive, which I have. It's a question of how many other people out there are willing to lift the finger and develop it themselves as well. And I see the most prime obstacle to that scenario is the monetary system and the slaves it makes all of us and takes away our options in life. That, no, I can't do that. I got to go to work. No, I can't do that. I got to pay my rent. No, I can't do that. I got to go pick up my kid from school. I have to drive to get there. You know what I mean? Those kinds of things. They call that life, and life gets in the way. And it still is, as far as I can see. It's getting in everybody's way. But I have never lost any grasp or grip on my own sense of life purpose. I guess I'm just waiting for the species to catch up.
Man, life's overrated, man. Don't worry about it.
It is what they say. Yeah. Okay. Well, I can go back. We talk about which one should we handle first?
What do you mean, Bedini or something else?
Yeah, precisely. We can cover Bedini and what I was doing with Core. So again, the self-exciting AC scenario is, it's again something the Globies do to shoot their own foot in terms of machine efficiency. The self-exciting coil is a misnomer, an egregious one, because really all they're doing is they're spending more input power to magnetize the rotor and the stator. You know what I mean? That's what the commutator is all about. Is where do we put the energy into this to make the pin spin? So I obviously I immediately saw the injustice in that entire energy equation and left it on the bench. For me, it's about moving magnets, not moving an excitable rotor. It's about moving something that's already got the potential that I want, interacting with the coils I have in the machine. So I don't have to pay for that, so to speak, in terms of my input power equation. So I spent a lot of time designing coil to move magnet in a way that during the off phase, not only am I harvesting that negative spike, but I'm also using the physical momentum of the rotor and the magnet's proximity coming into the next coil to magnetize it in its opposite polarity before the on phase, if you guys can picture that.
Yep.
It's an extra
100%.
layer of efficiency, that there is a physical attraction there even between the core material, which can be ferric and to some degree should be ferric to increase total efficiency of the machine, that it attracts. Did you guys come across Steorn? And again, this is like 15, 20 years ago. A dude in Ireland, Steorn. He was an investor, an energy guy. Did you guys ever catch wind of him? And that was a pun.
Familiar.
Wind, yeah. But
Sounds vaguely
that
familiar.
guy was just a ton of hot air. But he took this same root technology, I guess, mechanism that Bedini showed us all here, and kind of went his way with an even more passive method of driving it and using even more of the magnetic influence to induce the mechanical spin. For me, it's closer to a third of the action, and for him, it's a little more than half, I guess, if I was going to be crude in my analysis. Anyways, it would fill in the picture for you a little more of what I'm talking about in terms of my own work. But it's the off phase where I'm actually inducing forward mechanical motion of the rotor at no cost. It's the magnet that's doing that work. And it is the absence of the on phase in the coil itself that allows this attraction to take place. And what we achieve there is what is called a top dead center position, just like in an internal combustion engine before they fire the gas on the next one. You know, when the piston is coming up and you put the gas in before the pressure is up, and it does finally come all the way up and increase the pressure of the gas, then you ignite the gas. Right at that moment, that is when the rotor attached to the bottom end of the piston is driving the piston to its highest point, its farthest point away from the center of the rotor's motion, if you will. They call that top dead center in engine mechanics. Well, the same concept is kind of being exploited here, that I treat it mechanically as a top dead center where the magnet is coming as close as it's ever going to get to the core. And after that, if I don't fire the coil to create repulsion, the rotor would then again slow down. And this is the problem with magnet-only driven motors that you see out in the world, that there is the same drag. They try to create some geometric imbalance there, some type of magnetic shielding to apply to the space between them after the point of top dead center to reduce this drag. Well, I just went straight to the coil. I actually changed the nature of the field between the magnet and the core such that there is now repulsion, and that negates the magnetic attraction, so to speak, and creates a further mechanical positive on the rotor.
Do you have like diagrams,
comment?
schematics, visuals, anything like that?
Whole bunch.
Would you recommend your streams for that?
I would, as a starting place. And again, you could check out what Bedini and Friedrich did post 9/11 even. There's a fair number of their kits probably even now still for sale. But on YouTube, and I don't recommend anybody go to YouTube, but that's where they are. There are a ton of people who have replicated Bedini's work, starting with what they call the SSG, the Simple Schoolgirl Circuit. And they use a 10-speed bike wheel to mount their magnets and a hideously large radius to the rotor, because really what Bedini wanted to do in showing people the technology is where the energy interactions are and where they are not. And that's the clearest cut way to go about that first level analysis.
Wow.
Yeah,
Okay,
but
so I
definitely
know
check
that
that out.
I've heard that. Yeah, the Bedini motor definitely works. And I was gonna have you answer if you've heard of
Heard of who?
John Searle, the Searle
Oh,
motor.
Sewell. Yeah, British guy.
Searle,
Yeah,
Searle. Searle.
yeah. From what
John
I
Searle.
saw with Searle's work, it was all about series of magnets in cylinder shape, concentric within concentric within
I'm,
concentric.
I'm not an expert on his work, but I just know that, yeah, the Bedini and the John Searle are both
I
worth looking
I
into.
don't really know about Searle. When I look at the physicals of what he came up with, it it looks it doesn't look like anything more than magnetic field convolution to me. I don't see where he got an overabundance of positive mechanical spin out of what he was doing. I saw what I perceive to be, succinctly put, a lot of smoke and mirror.
Interesting.
It
Well, I
reminded
heard
me
that people
of
power in
Hansel.
their homes with the Searle motor, like that. That's something you
What
can
was that?
actually. Like, they don't allow sales of it here in the U.S., but power the Searle.
Oh, you're
I
cutting
think you
out
should
real bad,
Google
Dave.
that
You're
yourself.
roboting.
Oh, okay. I'm gonna. You know what? Can you hear me right now?
Kind of.
You're in and
Okay.
out.
I'll mute, but I just want to say I'm excited that limitless energy here. I don't know if you guys know each other. If you haven't. I'm excited for the two of you to talk.
If I don't know
Yeah,
who,
I just posted the Bedini version of the Pareto detector in the chat for you if you haven't seen the schematic and whatnot for it. It's not exactly a whole circuit, but it's a concept.
okay. Well, when I'm done yakking, I'll check out that YouTube. There is that the NO magnetic vortex one with Wheeler.
Yeah, it's like built in a Faraday cage and whatnot. And
Okay, yeah, we'll check that out. That sounds like fun. Yeah. Okay, where were we?
I guess you were talking about the
I'd
simple
like to.
schoolgirl circuit.
Simple Schoolgirl. That was the one with the 10-speed wheel, and they use ferrite magnets on them, and a single coil at the bottom, at the 6 o'clock position of the wheel, so that you only really have to look at one set of switching, so to speak, and that it simplifies how things look on the scope too. Brandon, you were saying something there?
I just wanted to edify something you were saying about the whole life getting in the way of people,
Yeah.
like quote unquote life, when it's really the money issue. They make you work. I don't know as much as you have expressed in knowledge terms of the energy production and the building of machines and whatnot, but I do want to, like I said,
You're
you're
roboting pretty bad.
the money thing. Like, people should really do whatever they can learn about this monetary system,
Could
because
you
there are
reiterate that?
ways
You're
to.
breaking up there a bit, Brandon. Oh, we lost him totally. Holy. Just when he said what he wanted to do, I missed that. Did anybody catch it?
He's back. You there,
Negative,
Brandon?
Ghost Rider.
Mm-mm.
Okay, you were telling us what you wanted to do. Start there again.
He might not be back. Oh,
Here, I'm turning off your
There you are.
video just in case. There it is. I'm just wondering if Toby's video was
causing me to lag because my internet's not great because I'm country boy.
I
But
feel for you, brother. I'm out
I
in the middle
just
of
urge
nowhere.
everyone to learn what they can about the monetary system because there are ways to, you know. Yeah. I just whatever people can do to learn about the monetary system, and me and there's a couple other guys on here, like Larry, for example, knows quite a bit about it. We're all like slaves to this monetary system, and anything that we can do to learn about it'll increase our ability to be able to do what you're talking about with the energy production, the machines. Like it's man, sorry I got here late. Hi everybody, good to hear y'all. Glad y'all are doing this.
Hey, glad you can make
I'll
it.
shut up now. You can continue. I just wanted to, yeah, I wanted to edify on that point that you had mentioned because like they really do have us trapped. Like on 9 to 5, whatever time you go to work and whatnot. Like, but there is a way out. It takes learning.
I would definitely agree, and knowledge is the key. And I would definitely speak on that if you guys got the time. I spent 5 years with the Venus Project volunteering in a number of their multimedia ended departments, as well as transcription. Eventually, by the end of it, I was their head resource for how to put together
The
their transcription project of all of Jacques' old
the
lectures from the 70s.
yes, Jacques. Okay, that's so cool, man. I was super into him, like into that whole project. Like I did some research on that. That's really, yeah.
So I definitely recommend people look up the Venus Project, but when it comes to today in this year, it's just being run by the wrong people, if you ask me. And
Yep.
again, we're even talking right up to Roxanne, and I know her personally. She even sent me some books. We used to talk regularly. But no, it's not even just her that's the problem. It's all the people who are surrounding her. They're all a bunch of fuckholes. they are
Well, you
really
have
setting back the cause, you know?
one bad apple, man, makes a whole bunch go bad.
Kind of feel
Oh,
like that
it's
with
the
Gaia
whole
too.
In this
bunch
case, it
though.
seems like the other way around, but
Yeah, they're spoiling the apple.
Gaia's like
No,
that now too.
but seriously,
unfortunately.
and when you talk about the alternative and you talk about the monetary system, it's actually they refer to what is called a resource-based economy, and the monetary system adheres to the monetary sequence of value. This is the thing that we were brought up with. This is the thing where they exploit the R complex we were all born with. This feeling that I better get mine before it's gone. This thing that we understand as possession. These ultra base root emotional concepts are being used against us in the inducement of the idea of scarcity.
Yep.
On Earth, there is no such thing. In any context, there is no such thing as scarcity of anything on Earth. But they would not have you believe that, because that way you're reliant upon a system to somehow get what you think is yours. And they snag you with it. And all along with the ID thing and all the other holes you can go down if you got a thing for rabbits. But, you know, it's, again, like flat Earth, like the concept, the issue, the issue of money is, again, an educational problem. It is exposure to the truth that is the obstacle. That if people would just know, oh, wait a minute, we don't have to use money. We don't have to own things the way that we think we own them in this context, the way we do now. That there really isn't, and I'm not talking about Klaus. Okay, I'm not going in the WEF direction at all, because those guys will only embrace the monetary sequence of value in whatever iteration they want to put it in. I'm talking about the life sequence of value. It is an entirely different psychological rooting in reality, where it is simply based on need, in the understanding of universal abundance. even in terms of human resource and everything on down. That when we talk about, okay, that guy's got an orange orchard and that guy raises pigs and the basic construct, he's got more than he needs. Well, what if everybody had more than they need? We wouldn't need to charge people for anything. It's just you need some here. Here, have it because you need it. Well, we'll just get some more. We'll make some more. Well, how will we do that? We'll just spend some resources on it. Well, that costs something. No, it doesn't. Nothing costs anything. We're just going to decide that we're going to put those resources into building or making or growing, producing more of that we as a species need. And when we do produce more than we need, everybody can have it for nothing. It's really that simple. The people in the way are the ones who want to complicate it. And that is why all of the social constructs that people have attempted on Earth for the past 150 years, communes and the like, just didn't get it right. In the same way, politically speaking, that you hear people now they call it socialism. They say, well, this time we're going to tweak it and it's going to be just right. No, you asshole, it's communism. It's never going to work. You know what I mean? We just have to come to the realization. And those are my comments about the monetary system. Once we get to the realization, all of a sudden, the obstacle is no longer existent, exigent. Anyways, so yeah, let's get back to physics. The motor. What did I not tell you about it? I don't know, man. And I mentioned amorphous alloys, and the closest I came for a decent core material was actually a welding rod made by Lincoln, no less. Again, something recommended specifically by Bedini, a particular type of rod they make, which is for gas welding, if you can believe that, not even arc welding. But it's got stuff in it that achieves this faster rate of magnetization and especially demagnetization. Because in this type of motor, it is the demagnetization process that you're harvesting, that you're adding to the equation, so to speak, instead of just resisting it, capacitoring it, and then feeding it to ground and wasting it. So what we're doing is we're learning how to use both polarities that are naturally there in the on-off phase treatment of a coil and using them both to make the engine go. That's one thing I wanted to comment about Bedini in general with this technology, if you want to use that word, the way that he builds this, and he says it many, many times. This is not a generator. It's not something that you produce large amounts of torque with. It's not that kind of animal. And one guy who really got it was this dude in Korea, and he filed with the WPO in I think the early 2000s, and what he did was he produced what he called an orthogonally based motor. And maybe I'll get the schematics up for that sometime. That is one where you really have to see it. And it involves those same laminations that I addressed way back at the beginning. And using 3 different axes of lamination orientation to your mechanical and magnetic advantage, if you will, such that we are eliminating the phenomenon of back torque. Do you guys know what back EMF is all about? And it really does relate to this negative spike.
Never heard of it.
Okay, well, they call it back EMF in the Globee world, and that's really what this spike, this negative, this decayed B field effect is. It's its whole other orientation of polarity that is untapped in the Globee world, and it's all about the geometry. It's all about the switching, and just knowing
leveraging that impulse, right?
What to do with it. Precisely. Leveraging. That's the verb I was looking for. Thank you. Yes. Where do I go from here? I don't know, guys. Questions?
Well, you said that. I mean, that's the problem with any motor devices that we can see a reaction or free energy from the amount of torque you get from it is usually the issue. So
I'm not quite hearing you.
Oh, okay. Probably my headphones.
Yeah, you sound real. It's not even just like robot-y. It sounds kind of just fuzzy.
Fuzzy distant.
Sounds like you're in an ether wind or something.
Try it again. Failure. Oops.
Bummer.
That's
sure
cool.
he'll be back.
Sure. Yeah. I'm just trying to gather my thoughts, really, what I didn't cover on the subject itself.
I find the impulse wave to be really fascinating in general. It seems to be, well, like this guy, Master Evo, he's got a YouTube channel, and he claims to have, he used 2 resonance coils outside of reverse phase with each other to produce a dielectric field between them, and he induces the impulse from Earth ground, and then uses that build back up of current from Earth ground to then build back up resonance between his 2 capacitance coils, and then basically he shows inducing like a current based around that impulse from the actual ground wire.
Yeah, I saw Evo. Did you see my posts in the Miswits channel on that?
Oh, no, I didn't. No.
Yeah, it's about a week or so ago when somebody brought him up. I first checked out that video in July, I think, when it came out.
Gotcha.
And I download everything, so I know when I watch things. I got modified dates. That's just an extra bonus to owning everything you watch.
Yeah, that's super
It's a great policy. But you're right. What he did there, I see, to succinctly, metaphorically put it, was resonant leapfrogging.
Yeah.
If that makes any sense.
Yeah.
Right. But if you go back and check my posts, you'll see in detail. So I won't really take a lot of time on it. But I don't think Evo has a good grasp on order of magnitude, especially in terms of capacitance and inductance, and how they interrelate to produce resonant function. Did that make sense?
So you think that
he says he's got 2 nanofarad caps in there, and then he's got a 25.3 nanofarad cap on the top. That's L3, I think, if memory serves, off the top end of the schematic on the top right next to the ground. That's where he puts L3.
Gotcha. Okay.
Right, and that one is supposedly 12 times the capacitance of the other 2 nanofarad cap that it's interacting with in producing resonance, at least in that part of the machine. And that's another issue, is that he has several different resonant frequencies running at one time because of the spread of capacitances and inductances that he's using. Just because of the physical way that he chose to make that prototype, there are a number of resonant inefficiencies. I don't even know if that's the right way to express that, but it's just things that aren't matching up that could.
Interesting.
And change the nature of how well that thing is working at the wattage levels he's playing at.
Ah, I see what you're saying. Okay. Kind of like would it be like transient impulses essentially, or?
Yep, that is another good adjective. And I don't think that he's pulling them out of the ground. I think he's pulling them out of the ether. Where are we measuring it? At the coil, right? At the cap. Remember I was talking about where to put it? Well, those are the 2 places. That's where we put it.
Yeah, it would come from the ether,
right?
Technically. It really would come from the ether around the coils, yeah.
I see ground as the place where charge resolves toward any of those prepositions. You know what I mean? That it doesn't play any more of a kinetic part than that.
And the act of the impulse. But yeah.
Yeah.
A place for the impulse to go. Yeah, a reason for the impulse to happen.
Yeah.
Yep.
It's a path. It is the end path. So I don't think that I really don't think that it's the place where you're going to get charge from. There's just far too much. Okay, what's the word? It's kind of like charge apathy. What's the word? Forget it. Doesn't matter. Anyways, I wanted to get into the nature of the energy that's running around inside this machine, Evo's machine, even mine as well, and it's the difference between hot and cold. When we talk about where to put it, there's the dielectric solution, and then there's the electromagnetic solution. There's the voltage, and there's the B field. And they are created and exploited in totally different ways in the same machine. We are taught that, coils do this and coils do that when you do this or that to them, and that's all we're taught. Okay, but we're not taught the nature of the energy coming out of them, and that it's different. That out of a capacitor or out of a coil, when the off phase is being initiated, that it's not relying strictly on the flux going through the conduit. But the B field itself is a function of the ether, the perturbation of the ether inside that coil's shape. Right? That it's an entirely different physical mechanism of storage, so that when you use the power, it manifests through the conduit in a different fashion. And that's really crude language, and I should probably take an hour and write it down so that it's even more clear than that. But what I see here is the difference between hot and cold power, and we see them in the machine itself. When I started with Bedini, I was looking at other guys like Harwood, Konzen, and a few others, where the question here for me is, how can I run my machine where I'm not losing it all to heat, to hysteretic heat, right? Well, okay, then look at the two types of power, because when we look at the on phase, that's where we're generating all the heat, both at the beginning and the end of the on phase. That when we increase the voltage, we're upping the flux that's going through the conduit itself, which has resistance. The copper resists dielectric flux. We all know this. That's what makes a light bulb burn, right? It's a very thin conduit with a lot of flux going through it that's resistive and producing heat. And it produces so much heat that we see it in that particular spectrum when we address Planck sigma t to the fourth black body radiation calculus calculations to figure out what color's coming out of the light. But that's how it relates. It's hot power. You know what I mean? That's heat being produced in the on phase. And we get that from capacitance. We store in batteries, we do whatever we do like that, and the power that is produced is like the hot electron, the red power, if you will. And again, this is a nomenclature problem between academics where people just pull out fucking knives. And they don't want to talk about it anymore. No, you asshole, it's red. Anyways, the other side is the inductive, and this is the off spike that I've been talking about. In the machine, during the off phase, when the magnet is approaching the coil, it's sending the opposite polarity, magnetically speaking, across those conduits of the coil, across the wires. It is, how do we measure the magnetic field? It is those cleavage planes we are crossing. We move it through space, and that's how we know there is a magnetic field there. Well, the same thing's happening with that coil when it's off. Magnet approaching, it is essentially producing a south polarity within the coil relative to the on phase, B field produced where your thumb is when you turn it on, if you know what I mean. Well, in the early machines that I was building, where I was rotating a couple of compact discs glued together with 4 neodymium ferric boron cylinder, nickel-shaped magnets on its circumference, norths all pointed out, spinning that facing 2 coils at 180. When I was doing all that, The magnets have a lot of throw. They've got a lot, like the Gauss value on them is extremely high. So we're producing a very strong other polarity in the coil before we turn it on, so to speak. Well, that is what we call the magneto-electric effect, not the electromagnetic effect, which is what is in the right-hand rule diagram. Right? That's the electromagnetic effect, where we're running power through the coil to produce the B field. And all EMF in the air, Wi-Fi, everything else, all cellular communication is nothing more than that. On and off of the coil, B field shooting out the end, using the hot end. That's all EMF is. Well, what we're doing is we're taking that coil and we're running flux in the other direction. We're actually creating negative voltage relative to what we're pumping it with in the on phase in the coil before we turn it on again. That's where that bolo bat action is coming into play that I was talking about when we're approaching top dead center, just before we turn it on again. That in itself serves to reduce the amount we're spending in the on phase to produce the repulsion to drive the magnet further on the rotor. You guys following me? That
Sorry,
there's a
say that
little
last
bit
part
of
again.
I am.
there's a little bit of dielectric sponginess, if you will, elasticity, compressibility within the conduits of the coil itself, that you're hitting it with a south, so to speak. It's producing a negative voltage, although it's not a closed circuit at that moment because it's not switched on, right? And as we switch it on, we then essentially collapse the negative B field or the south B field that's in it and use that, again, to our advantage to create the repulsive force. This machine's coils run cooler than ambient air. Ask any Globy engineer how to do that, and they'll tell you it's fucking impossible.
Wow. That's super interesting.
Yep, he's right. They don't understand.
And that's what I'm about.
Wow.
So I'm still looking for people who want to build them, you know?
Are you offering like instructions essentially, walking people through it?
I have always openly offered that, as well as a way to develop an electrostatically based generator, taking the voltage right out of the air. We talk about this picoamp per square meter, but
Yep.
you guys realize that that in itself is also put up as a mental psychological obstruction to everybody, similarly to how they use the Flat Earth Society op website to convince normies there's nothing worth looking into here. That they present it the same way. There's just nothing you can do about it. You know what I mean?
Subterfuge. Yep, subterfuge.
It is. It's exactly what it is. They say, well, you know, that's just all there is to that concept. Let's move on to something else. And it's like, well no, wait a minute and a half.
I know that Limitless is holding back because he's actually.
Shut up, fucker.
I'm sorry. Yeah, I know you're holding back, man, because you guys got to talk. I just want to hear it. Come on.
Hey, anytime. So
Let him
what I did
preach.
it was last year actually that after a lot of people in the Stone Cold Truth channel, which used to be called the EWAR channel, because EWAR spent a lot of time in his documentary early talking about the electrostatic thing and churches and all the pointy stuff they have in the air on the tops of their buildings, and exactly what I told you about Notre Dame and how that corroborates that. You know what I mean? That last year there was a lot of psychological momentum in the gang, if you will, a lot of interest. And so that's when I made a decision. I said, okay, well, shit, give me 15 minutes, guys. I will go design something and produce a schematic, a circuit, and a list of parts And I'll even tell you where to get them. And I'm looking for people who want us to sign a participatory contract with me where I will actually help them build it where they live. Like, I don't have to be there. And frankly, for me, the motivation for that on top is that I have such a hard time getting things into Uruguay because there is this socialist importation mafia down on the docks that are totally in my way, you know? So I'm
Interesting.
looking for people who want to lift the finger. And I am just more than willing to spend as much time as it takes to get them built, to get them prototyped, to get them tested, to get them developed. Not necessarily sold to anybody else in the world. That's your option. You know what I mean? But if it comes to that, I'll even help you build the business.
So you say you've been successful with the build, and you just want other people to do the same.
Check my data, man. But when it comes to the electrostatic one, no, I haven't built it here. This is the nature of the problem. This is why I was soliciting participation, and still am. So yes, to
Yeah,
answer your question,
we need
the
to
answer
do
is
that
still
one
yes.
together.
Yeah, man.
That's
Yeah,
one you don't want to do that one on your own, dude. Don't do it.
No, well, I hope you keep talking Limitless, because you guys would be great to hear exchange, your build ideas. But we were talking about this just last night as far as EWAR's collection of etheric energy and the use or the hints that were given with the legend of Opharus with the Christ child on his shoulder, and the Christ child was representing the gold, with the Opharus being the mercury across the current of the river. So is that what your build is all about? The mercury with the lead in between the gold, so that there would be a spin action of some sort, or we're trying to figure it out?
No, it's not like that. The mechanism is almost purely capacitive.
Yep.
And what I'm doing is I'm exploiting the potential. You see, and again, when I said this picoamp per square meter being the obfuscation, being the obstruction here, that you've got to look at the words they use. It's key. What they're saying is, in atmospheric free space where you stand on the surface of the Earth, that's the potential for flux that we measure. Okay? What they're not talking about is anything to do with potential. Wait a minute. If the potential is so good, why aren't we looking at spark gap technology? And that's where Tesla started out. If anybody looked at the first of his 120 patents, the first 10 or 15 or 20 of them, it was far more to do with speaking in terms of high voltage, low current, because it's just more efficient, right? Well, all of that is because of lightning, that the voltage is so incredibly huge up there. What we really need to do is not just create the conduit between here and there to allow faster current flow, but we also have to use what we know about spark gap technology to create the input device that we put up there to harvest the voltage potential and bring it down through the conduit. That is how you up the current. And you're totally right. It's not a thing you want to be messing around with on your own if you don't completely know what you're doing, because the system that I designed runs at about 2200 volts DC before we talk about the AC generation on the other end for public consumption of the machine.
So real quick, what was the mercury and gold? Could you give us your interpretation of that story, and what the reason was that the mercury and gold was used?
Yeah, it's about the technology on the downstream. You see, your power generation mechanics have to suit the appliance, right? It's a question of how did they build their hardware that they used with the way they were pulling the power down. And the use of mercury itself is the enlightened option to brushed commutation, if you guys know what I'm talking about there.
I don't. I'm sure Limitless does, but I don't.
Okay, that's right back to simple DC motor technology. How do they excite the rotor inside the motor, which is encased in magnets in the cheap DC and of what you see in that technology. It's just all they're doing is they're flipping the polarity inside. They're playing off both the north and the south parts of the physical magnets inside to create multi-phase positive mechanical force. That's all they're doing. And they separate what they're doing inside through a system of contacts on the rotor pin itself. And they use brushed contacts on that to essentially create the timing of how the motor works inside, which polarity fires when.
So would the mercury act like a lubricant almost, like a lubricant conductor?
It's the thing that eliminates the brushed commutator altogether. You see, as a physical part of switching on and off. And you see, I don't know how to bring that one down to the ground for you. In a brushed commutator system, and again, this is something Tesla worked up even into the megahertz frequencies. If you can picture that, this gigantic rotor standing next to him, 12 feet tall, spinning at umpteen thousand RPM with, a couple of hundred strips of metal transverse mounted across its circumference, right? So that the physical brushes that are on the outside touching its edge as it spins are completing circuits, positive and negative, alternately through it as it spins. The brushes come into contact with conduits going through the rotor that produce flux through the rotor in both polarities. That's what brushed commutation was all about. That was the solution to produce AC or pulse DC or anything else of that animal.
Oh, okay. Speaking of AC/DC, recently we were looking into the what was it called, guys? The plasma. It was a arc generator. The plasma arc generator. What's it called? But it still powers an elevator. Somewhere. You guys remember we're talking about that over in Geos? No? Okay.
Keep talking about it. You might trip me on it. I'm not there yet.
Yeah, it was a plasma arc generator. It was basically like a Tesla type bulb that was changing, converting DC to AC, and it had enough torque to lift an elevator. So I'm not sure exactly what the design was, or I'll find it and post it. But back to the real quick, the mercury with the gold. The mercury with the gold, is it about the amalgamation or the attraction, like the gold is trying to get to the mercury? Because that's kind of what we were trying to speculate about. Like, why was it the mercury? Why was Ophrys and the gold, Christ on his child with that little gold orb that the Christ figure is always carrying?
I can help you there.
What were the clues there? Yeah, what was that
I
all
can help
about?
you there. And again, back to brushed commutation as a poor alternative to the solution you're talking about. This is how do we connect the sky to the machine, literally, in an on-off fashion, right? This is what it's about. Okay, so when we look at brushed commutation, that's just a slice of copper welded on the end of the conduit that's touching more slices of copper that are welded onto the conduits of the rotor that's spinning. And in between them, you got your voltage coming through the conduit to the rotor through your brush, touching it. So then they use a lot of carbon, and they use a lot of things that can handle high temperature sparking between the two, because you're physically making energy jump from the brush to the rotor plate that's spinning. This is the commutation, so to speak. When you do that, you're not just creating a wear friction point and heating them up because you're spinning it. It's the electrons or the sparks that are being generated every time the rotor moves away from the brush and breaks the connection. And it produces a lot of carbon. It oxidizes a lot of crap in between the two, right? And degrades the connection and basically tries to stop.
Got to go in there and whack it every once in a while.
You
to
have
get it
to
working
clean
again.
them constantly, right? Yeah.
Yeah,
So
dude.
This
People
is
don't know.
why
Just
they
go and
use
whack it, and
gold
they're like,
instead
"What
of
the
copper.
fuck? Why did it work again?"
Yeah, this is why they're using gold instead of copper, because copper oxidizes and turns green, and gold does not. Okay, that's it. That is exactly why. And the mercury is the thing that they're using inside mercury switches for thermostats on the wall. You guys seen those? You ever open up the
Yeah.
old school thermostats?
Yep.
And when you tilt the bubble back and forth, the mercury moves away from the contact, and you see the spark right there. But nothing else is produced inside the tube. All you see is the spark, and then it's over, right? That's because you're using mercury and not a brushed commutator or whatever else, a liftable switch like every light switch you've ever seen in your house. You know what I mean? All that is a liftable switch. You're just making and breaking physical contact, copper to copper, inside that switch, right? And that's why you see them spark and sputter every once in a while, because after you flick it 10,000 times, there's a bunch of carbon and crap in between, and then, just like lightning, that charge starts to look for somewhere else to go because it can't find it where it used to because there's so much shit in the way. That's why they're using the gold and the mercury solution.
Gotcha. Okay, so then also, as far as mercury goes, because you mentioned thermometers, what's your take on red mercury? Myth or fact or mystery or what?
I really don't know what to think about red mercury. It brings me back to the original, again, globy assertion that mercury's bad for us. I wonder why they're saying that. I'm sure you guys
Right.
are keyed into that one, right?
Yep.
It follows. It follows that same psychology. So again, it's something I can't really get a hold of, and it's time. I I I will say I don't really have that much time on Earth to also check out red mercury at this time where I'm at in Uruguay. I don't even know if I can ever get it here. You know what I mean? Produce it.
I mean, you
Not that
can make it if you
I've
really
looked into
want.
how to produce it. I heard that coming. Make it.
Mm-hmm.
But yeah, I would be interested in looking into it for sure. Yeah.
That shit's fucking dangerous.
Yeah, why? Why is it dangerous, and what is it? What's the
Because if you
properties of it
if you
compared to
add like
regular mercury?
enough radiation to it, it'll literally explode on you.
Well, why? Okay, so it's really it's useful though
It's
because
volatile.
it's volatile, but that means it's useful as well, right?
Yep, pretty much.
There are two things in the universe rather, and I really mean macroscopically speaking, where I express it in the terms of this thing is not your friend. One of them is dielectric potential. Electricity is not your friend. It will not hold back because it likes you. Let's just put it that way.
Yeah, exactly. You got to know what
You know
you're
what I'm
doing.
saying? It don't know you from shit. It's not your friend. And the other one is a solid concrete floor. With porcelain in the kitchen, for example. Yeah.
Insulator.
Is that because you get shocked and then you hit the floor? Is that your
No, it
indication?
means if you drop anything on a concrete floor, it's toast.
Oh yeah, right.
Blastification. Yeah, that's what I
especially
mean
your
there.
glass.
It's not your friend.
Yeah.
Well, cool, guys. So that does line us up for some good discussion vectors in the future. I think that's awesome. Very encouraging.
I got a whole team of people who will build it.
Bitchin'.
I might not be able to get some of them to do it, but
it's always that way. Some are ready now, some are ready later. Some have to see it first, some don't. You know, those are humans.
Yep. Well, we are visual. You do a good enough, schema and whatnot that's got labeled and whatnot and legend decently enough, and there you go.
Well, I appreciate you coming through, Stone. It's been super fascinating stuff, and it was like a perfect follow-up to just really, really go way deeper on the stuff I touched the surface of.
I couldn't be more pleased at the reception, guys. Many thanks. And totally as a tangent, I look up on the tableau here. What is it? 16 of you in the view here, 17, and I'm looking up top, and the only guy that we haven't heard anything from is Sacred, and he's the guy that I would definitely hand the kudos to for being the moderator in the light constantly as much as he can be. That's Yeah, points. Major points scored, dude. That's all I gotta say there.
Yeah, shout out Sacred, man. You there, Sacred?
Maybe I blew his mind.
Yeah, he I can't believe they're like 83, 82, 83 deep now. Over there at Flat Earth Fridays. Pretty crazy. And it shows.
Yeah, sometimes I miss mine.
It shows.
I got a first
Sacred,
Friday meeting of the month every like month for like the last couple of years. So sometimes I can't go to them.
Yeah, that's more of that life stuff. Yeah.
Yeah. Well, it shows because Sacred's real patient, man. He seems to have been through it a few times because he seems like he knows what he's doing at this point.
Yeah, it really is a question of length of exposure, you know, more than anything else. You just need to see it over and over and over, and you eventually just become fluent.
Yeah. Makes
It's
sense.
called the Mercury Arc Rectifier, by the way. I sent you the links and put them in the chat.
Ah, now that does ring a bell. Yeah, I'll take another look.
Well, I think maybe we can close out the stream here then, unless anyone has any other final thoughts or anything. Any other questions for Stone, maybe?
I'm just
Any that'll start another conversation. If we don't just cut it off, it's gonna go forever. But amazing. I'll definitely check out your work, and I hope you come back and talk with us all the time.
Yeah.
Sure thing.
Yeah, I really hope you come back sometime. If you ever want to schedule something, if you ever want to like give a presentation or something, we'd be really happy to do something like that. Or, I mean, feel free to pop in.
I think that might take the form of a review of a video or videos that I've produced, or
okay.
anything that's hot off the shelf. Like I've got 3 now in the works. There's the FOG stuff from Bob Nodell, right? That entire horror show of data. I'm through it all. I've produced summary, like numerical summary. I've grafted out the yang. You know what I mean? It's charted. I know exactly how they did, what they did, and how well they didn't do. And that's going to turn into a video, frankly, that a lot of people are just going to turn the flame on. They're going to be so pissed.
I'm sure it'll be fine.
Hey man, facts are facts. I can't help that. You know what I mean? They just are, and people need to know what they are. It's not about what you think before. It's not about what you believe. That has no reflection on you. Ego prevents. You know what I mean? So that's one of them. I have another one on plasma, and more specifically the CME, the coronal magneto ejaculation from the sun, and what they say about that. That's 2, and now this is number 3. That yeah, we've got to do one. Oh, what did it was last night. Yeah, I don't know. Everything's such a kind of a blur after that. I always hear him from The Simpsons.
Dude, you did a really good impersonation of him. That was on point, to be honest with you. I was like, yo, dude's here from The Simpsons.
No, it's the third one about the Marmé paper you guys were talking about last night, and the C plus V argument.
Yeah, see that. What's got your eye there?
I don't think you guys are gonna like what I have to say. And I really don't want to let the cat all the way out of the bag here just yet. Just that it's coming, and that could be something we spend another half an hour or an hour talking about. You know, once it's out, once there's something we can point our finger at, and we can look at the points and okay, now let's talk about 2.5 minutes into the film. This is what we want to address, and we can be a little more prescribed about it.
Looking forward to it.
Sounds good.
It's a plan.
Well, I'm going to go back and listen to everything you said when I'm not so busy and take notes and definitely.
Are you able to do that? Is this recorded?
Yeah. This is still the live stream, right?
You can just bug over to YouTube. It's all right there.
Nice.
Yep.
Good. That's good for people. Thank you.
This is on Æther Cosmology YouTube and also on the Space Audits YouTube live right now.
Yeah, the YouTube file name will be Æther, A-E-T-H-E-R, roundtable number 15.
I love that, by the way. That's like, I don't know. It's got so many great uses, I'm sure. Especially with, like, YouTube doesn't even properly let you, they don't even give you a proper index to search against. So having the files yourself is pretty...
It's the only modus operandi I find acceptable. YouTube is just such a draconian whore. I cannot handle it. I hate
What are you
YouTube with
using?
a passion, you know what I mean?
Yeah, I like to use Odyssey lately. I stopped using YouTube too.
Well, cool, Alan. Should we close streams out?
Yeah, we can wrap this. Totally, man.
Yeah, I'm go ahead and wrap it up.
You want me to say what Mercury, red Mercury is? You want the formula?
No,
end it off, or should we
just
keep
get that in
private?
Toss it all into the Miswitch channel, and we can banter about it there.
There you go. Yeah, that might be dangerous.
That sounds good.
give
Yeah, it
out.
might be dangerous for me.
Definitely DM me about that. Though.
Yeah, sure. Anybody can find me. I'm at Man of Stone on Telegram. I'm easy to find.
Excellent. Well, cool. Thanks, everyone, for tuning in. This has been another fun time here, and fantastic crew here. We are so lucky. Stone, thank you so much for popping in and enlightening us with so much information. And, yeah, we'll really look forward to having some more conversations with you in the future, if you will oblige.
Most excellent.
Awesome. Well, thanks, everybody.